Good morning, everyone.
Ladies and gentlemen.
Welcome to Reactathon Day 2.
Welcome to the stage.
Woo!
Your MCs for
We're
day
excited
2
to be back in person. I'm Mars.
And I'm Jim.
And we're both hosts of Front End Happy Hour. Welcome to Reactathon. Can we go to the next slide, please? Thank you. So before we get into today's program, we're first going to introduce some of our sponsors. The presenting sponsor for this year's conference is Clerk. They go beyond the sign-in box and provide component-based authentication and authorization and full account management. So if you just add a sign-in or a user profile component, that will get you your user management. They also have a big booth in the expo downstairs, so please go say hi. We also have other support from these other incredible companies. They're also exhibiting in the expo hall downstairs and are staffed by senior engineers. Each of these companies are pushing the boundaries of web development, and we think you're going to love chatting with them, so go say hi to them as well. And as a community event, Reactathon cannot happen without our sponsors. So let's have a quick round of applause for everyone downstairs. Okay, now to Jem for our schedule of events.
First one is our first break block will be 10 to 1, 2 talks plus 1 expo break from 10 to 2:40. We'll have lunch in the city. There's a custom map in the Slack group for recommendations, restaurants, cafes within the area. This is a really nice spot to go walking in, just mind the hills. At 2:40, we're going to return for the talk for Demetrius Clark on your deploy previews with Zada. And then 3 to 5 will be the final block of stage talks. And then we're going to have a talk on AI, which is pretty exciting. I know I want to learn a bit more about that. AI is changing not only the way we write code, but really our entire industry and our profession. Don't miss these sessions on the future of web development and software engineering in the age of AI. Very exciting block of talks there. And then afterwards, join us at Hotel Kabuki for the after party with a live band, food, and a cash bar. So we ran through our scheduled events. There's a Latent Space podcast with my friend Sean on AI web developments. I think Wes is going to be on there as well. So that's going to be pretty exciting. You don't want to miss that. I love late night podcast recordings because you never know what's going to happen. I say that with a wink. Like I just mentioned, we'll be closing out the conference with a live recording of the Latent Space podcast. This high signal AI podcast, for those who don't know, with Sean and Alessio. They'll be talking more about the future of web development in the age of AI with special guest Wes Boss, as I just mentioned. That's a big group of names there. This will be a really exciting and fun event with a really excellent vibe, complete with a live band on stage. So podcast, live band, nothing's going to go wrong there at all. It's going to go smoothly, I promise. They'll be at the Boom Boom Room. That's a historic, intimate venue just 2 blocks west of Hotel Kabuki. You really don't want to miss this one. If you have time, go check it out. So now for a bit of housekeeping. As always, with a conference, a bunch of people you don't really know, not necessarily your friend group, hopefully future friends, you always want to make sure you read the code of conduct and abide by it. The #1 rule, of course, is be good to each other. Follow the Pac-Man rule when it comes to conversations. Always leave an opening in your conversations and let someone new in. You know, when you have a closed-off circle, just step back a little bit, let someone new in. You'll make some new friends. I promise. It'll be that's the way to do it. Lunch today will be off-site, so head to one of the many restaurants within walking distance, and don't forget to reference that custom map that's in that Slack group, and you can come find me for recommendations as well. I'll just point you. I won't help at all, just point in a direction and assume there's a good restaurant in San Francisco. If you don't see the email with the map link, scan the QR code and the resources banner by registration or in the expo. There's a Slack group. Join the Slack group to connect and stay connected after hours with the friends you just made. Scan the QR code to join the Slack group. It's in your resources and it's all over the place.
So yeah, let's get this started. We first have Wes Boss up with our first talk, and we'll let him take the stage.
Thanks a lot. So I wasn't made aware of all the that weird stuff is going to happen at that thing tonight. And also, I wasn't made aware that it was at a place called the Boom Boom Room. So, buckle up. Hey, everybody. Thank you so much for coming out. I'm pretty stoked about this talk. Hold on. Got to turn this thing on. There we go. My name is Wes Boss. I'm a full stack dev from Hamilton, Canada. I'm at Wes Boss on Blue Sky. That's it. Anyone else on Blue Sky yet? Any losers don't have invites yet? Oh, boy. I make web development courses, as well as I have a podcast called Syntax. Anybody here listen to Syntax once or twice? Yeah. So this talk today here is about server-side JavaScript. It's specifically about the different JavaScript runtimes. And what a runtime is you take your engine, which runs the JavaScript, and then you take your APIs for things that us web developers use to actually interact with the runtime. So that's what a runtime is. There's kind of three main engines out there right now. There's several others, but these are the big ones. You got V8, that's the one that runs in Chrome and Edge and Chromium and therefore runs in a lot of other places. You got SpiderMonkey, which runs on Firefox, and then you have JavaScript Core, which runs on Safari as well as the PlayStation browser and several other ones out there, right? Those are our three main engines out there. So we have Node on the server. We have Node that runs on V8, right? Now we have Deno, which also runs on V8, and that's Deno deploy, Netlify edge functions, Supabase edge functions, a whole bunch of the other ones. Now we have Cloudflare workers that actually also runs on V8. That's what Vercel edge functions are running on as well. We have Bun, which took the JavaScript core, the Safari engine, and they're making a new server-side runtime as well. There's Fastly Compute, which runs on SpiderMonkey. There's Alibaba Edge Compute, which runs on V8. And those are just the ones that you can sign up for. There's also things like the folks from TikTok and Bloomberg are also working on some cool stuff as well that are running V8 projects. So if my math is correct, we have like 3 browsers to sort of target, but we have 6 server-side runtimes that we could possibly be targeting, which is wild to think that JavaScript there's more environments now on the server than there are in the browser. So you might be thinking like, oh my goodness, are we going to have IE 6 of the server at some point? Like, is this not... Can't we just stay with one and stop changing things and it just will run in one place? So the question we have now is like, why do we have all of these different runtimes? Weren't we fine with just having Node? So the ideas behind this is that it's better. We have things like TypeScript support right out of the box. You don't need to compile it or transpile it and do all these weird module things. There's a major push for having standard APIs, which is what this whole talk is about here. They're all to the ESM spec. They have things like being able to import from a URL with a module. And then there's just like a lot of like easy wins. Like, you know, when you're building a Node app and you're like, oh gosh, I gotta install the .env plugin. And you know, like there's like 8 things you need to do before you get up and running in Node. At least for me, I write a lot of little scripts, a lot of little packages, and it's really nice to have an environment where like you can just start writing code and it just, all that sort of setup is left behind. It's really just a joy to work with. Faster. So I'm not gonna stand here to spout numbers at you and whatnot. Honestly, that's not really my forte, but you're gonna hear things like cold starts and Rust and WASM and asynchronous, non-blocking. You're gonna hear a lot of these things being thrown around to say that these environments are faster, and we'll look at why that is and what the limitations of those are. And then like stronger as well. Like, so Deno was built by Ryan Dahl, creator of Node.js. And from the get-go, Deno says, okay, you get access to nothing, kind of like your Mac, right? You have to approve every single thing in there, and it will tell you anytime you want to access the network or be able to write to a file or read to a file on your local network, and you can give it access to a specific thing, which is probably a good thing when we're all NPXing these random scripts from random dudes on the internet and be able to run them on our computer. So let's talk about the different server kinds. We have 3 kinds. We have the traditional long-running VM, with the server. So this is you go get like a DigitalOcean box and you type node index.js and you're running your server until it falls over or you stop it, right? They're always running. They maintain memory entirely the application. To scale up one of these things, you give it more memory or more CPU, or you do more servers and you just load balance them based on the traffic coming in. Then, a couple years ago, we got serverless functions, which everybody loves to talk about how there's still servers. They only run in short bursts when needed. So somebody hits a specific serverless function, it starts up, it runs the code. To scale a serverless function is it just runs more of those functions if it needs to. And you really just pay for what you need. So you're not necessarily running a server for something that gets hit once a month or every so often. Now we have this thing called the edge, which sounds really cool. And they say we have edge functions. So like, what's the difference between serverless function and edge functions? Is they're pretty close to each other. Edge functions generally run closer to your user, so they're distributed to different data centers around the world. They can run in between your requests. This is a really good use case I'll talk about. They have a limited API, so they don't have the full-blown node compatibility, although that is starting to change as well. And then they generally bill you based on what's called CPU time versus wall time, meaning that CPU time is, let's say you loop over an array of 6 things, and then you make 6 network requests. You're only paying for like the loop over and then the start of the network request, and then when you're sitting there waiting for the request to come back, you're not paying for that time to run until it comes back, and then you work with the JSON data or whatever that comes back. So like, what are we supposed to do with all these different runtimes? Are we supposed to support all of them? And the answer to that is kinda, yeah. But the answer is JavaScript, right? JavaScript is how we're going to support all of these things. So we have 3 major standards bodies right now. We have TC39, they're responsible for like the actual language itself, async await, const, ECMAScript modules. And then you have W3C, their WebRTC, and the Streams API, and web components, and then the WhatWG, they're responsible for fetch and other properties like that. Now, how many of you have installed this thing in the past, right? Probably everybody in this world has installed it this morning already, right? 45 million within a week. And like, why do we have node fetch or isomorphic fetch as a package when shouldn't it be built into the language? And the answer to that is that fetch was like a browser API. And the reason we didn't have it in the server is because it was a browser API, right? So there's a new community group called the Winter CG, which is built up of all of those companies that I just showed in the earlier slide. And their idea is to make sure that we have standards that this JavaScript is going to run on all the environments, and we're not using specific APIs for every single runtime. So browser.js is server.js. We don't need different ways to do the exact same thing. And that's sort of the whole point of this talk, is that code you write in the browser will also be code that you can run on the server. So let's take a look. Probably the biggest one is the fetch API, in that requests and responses are live, both on the server and on the client. So when you have the browser, you make a request, you use the fetch API, right? And what you're really doing there is you are creating a request, and you're getting back a response from the server. And on the server, it's the exact same thing. When you get a request coming in, if you've used Express or whatever in the past, that's not a web request or a web response. That's a custom node thing. However, if you've written a serverless function or anything like that, you may have noticed that this pattern kind of looks the same across all of these different servers, and that's because they're all based on the fetch standard. So I took this function that we have right here, and if you want to run it on Dino, it's the first one, and the second one we're running it on a Bun server, and the third one we're running it on Cloudflare. The fact that that handler can intercept or have a request come in and work anywhere is actually pretty cool. It's not native in Node yet. However, there are lots of plugins, Hano.js, Fastify plugin. You probably have used it before in Next.js routes or SvelteKit or Astro or anything like that, is that this is a standard. And this is what allows all of these JavaScript frameworks to be deployed to anywhere, right? The next one is web streams. You basically can chunk your data as it's coming in. So streams are the ability of your server to send data to anywhere, really, probably the client, from the server to the client before the server's even done. So if you're rendering your React application, and your React app says, well, I'm not done yet, but I've got the header, or I've got like parts of it, you can send that data to the client. You can set up the request. You can do all the headers, the handshaking, all of that stuff. And while the server is still rendering out your application, the browser can actually have a bit of data as you're going in. That's really cool that when you're using web streams on the client, you can make an abort controller to cancel the specific request. And then on the server, you can simply just run a cancel method in your readable stream, and there's no libraries, there's no extra if statements, there's no code. On top of that, by just using web streams, the client and the browser can talk to each other without having to have some sort of intermediary layer. If you have rendered streams in a React application before, you notice, I don't know if you've used this, but a lot of frameworks use this under the hood, right? And in order to make it work on all of these environments, we just use render to readable stream. Why? Because that is a web standard, and it will work literally everywhere. It will actually, Node.js has their own streams, but they also have web streams now, right? They support it natively, and they have a really nice compatibility layer if you have a Node stream and you want to convert it to a web stream, which is great because, again, browser code, client code, server code is the same thing. Events. This is actually kind of a really interesting one when I first saw it, is that events work anywhere. Like, if you take a look at this code right here, add event listener, you might think, oh, that's a vanilla JavaScript API. But in reality, if you run this in the browser, it will work. If you run it on the server, it will work as well. So the same syntax, and in some cases, the same events, will run on the browser and in the client. You can make your own custom, so they all extend event target. So if you want to say, all right, my application is interested when a user is updated, or like I took an Uber here from the thing, and after the Uber was done, it popped up a little thing that said, hey, do you want to book your flight home, or do you want to book your car home? And I thought, oh, that's cool. They're probably firing some sort of event like ride over, and then there's somebody else in the application listening for ride over, and when that happens, you can do things like throw a pop-up or log some data or whatever it is that you want. The form data API. So how many of you are using Remix in here? Not a, oh, pretty good. So the form data API is actually pretty cool because, again, it was a browser-based API for being able to collect data and set it in this specific object. And you can pass your form data to the body of a fetch function. Well, that code will work just as well on the server side. It's a great way to be able to architect your data before sending off a request. Web workers. Web workers allow you to do multi-threaded. That's always the thing. Everyone says, well, JavaScript's not multi-threaded, but you can make it multi-threaded if you throw it into a web worker, and you can have stuff running actually in parallel, not just concurrently like a single wait. That's great for CPU-intensive tasks. It's non-blocking. Service workers-ish. I put ish on there because it's not actually supported, but the whole Cloudflare worker runtime is based on the service worker API, and it's really nice for intercepting requests. So right here, what I have is I just have a handler. There's that request that comes in that we talked about earlier. What you can do is you can fetch another website, get the HTML back. You could, in this case, I'm just waiting for it all, but you could stream it as well, like we were talking about. You replace a specific word on the page, and then you simply just return it out the other way. And this is an extremely popular use case for edge functions because you can write code that sits in between the request in the actual end server. So even if you are using any server, it could be a Rails app, you can still put a little bit of JavaScript in between that request and be able to intercept it and grab it. And that's good for A/B testing or country-specific stuff, or if you want to be able to add some specific logic to a request without actually going into the application code base, you can write a little bit of code that sort of sits in between. So why is this useful? Well, proxying. At the very least, you can take one of those event handlers that I was showing and write a one-liner, return fetch reactathon.com. And what that will do is it will literally just proxy the entire website for you. So if something is blocked at your work and you can't get onto it, you could write a 3-line proxy to proxy the entire website through a different domain name on the server side. Back to the proxy. Another cool example that I did was I use Cloudinary. Anyone use Cloudinary here? To process and resize your images and whatnot, and I love it, but it's kind of expensive once you get past the free plan. So I wrote a Cloudflare worker that sits in front of Cloudinary and said, when somebody requests an image, if it doesn't exist, then just pass it along to Cloudinary and they'll resize it and whatever. But if it does exist, then just cache it, and you can just cache it on Cloudflare or cache it on your own CDN. So you get all the benefits of the SaaS, but then you can just cache it in your own little CDN, and you're not paying for the overhead. I'm sure they don't like me telling you that, but it's kind of cool. I open sourced it on GitHub. Add custom CSS to a SaaS. So I have this Cloud App screenshot tool, and it doesn't look very good, and they removed some functionality that I really liked. So I said, well, screw you guys. I'm going to add that functionality back. So I just put a Cloudflare worker in between, and this could be an any edge function. I put it in between the SaaS and my domain name because I had a custom domain name. And what it does is it intercepted the request. It went and got the regular page that people were expecting to get. And then on top of that, I added a little bit of CSS. I put a custom logo in there. And then I added in some functionality that didn't exist anymore. And then I took out their branding because I'm paying for it. You don't get to put your branding if I'm paying for it, right? And it's so cool because now that if you have literally any SaaS, you can just add your own code to it. It doesn't have to be a browser extension. It can be a worker that sits in between it. Migrating slowly. We see a lot of people do this type of stuff where they say, okay, we are going to be moving to React from whatever monolith that we had before, but we need to do so slowly. So what you can do is you can request the old site and then just incrementally replace the header or the footer or the sidebar or specific parts of your website with your new version without your old server having to have buy-in for that type of thing. You can sort of just replace it on the fly. We see that quite a bit as well. This one's a little bit silly, but I think it's pretty cool, is that alert, prompt, and confirm work on the server. You can, and this is really handy for writing CLI apps, where you can alert somebody, prompt somebody, and confirm somebody. And if you're writing a CLI app, it will just pause the input, allow you to type in things, press yes or no, and then return to you your actual data, as well as the console log with CSS coloring actually works in the CLI as well. You don't need to go get the node color package or whatever it is to do that type of stuff. Async local storage. This is a really cool Node API that Node came up with, and it's actually pretty interesting. So the way that it works, and the problem that async local storage solves, is that you can access and create a store inside of the context of a function, meaning that let's say you have a request coming in from your server, and that request needs to call 7 or 8 functions down the road. Generally, if you want data to be available to all of those call stack functions, you need to pass it from one to another, which generally, yes, that's what you should do. But sometimes you just need stuff to be available everywhere. And that's when you get into things like putting data on the request or having some sort of context object where you can put stuff. So async local storage will allow us to create a store. That's what that enter with is right there. And then any function that gets called down the call stack or down within the context will be able to reach out and get access to that store. Now, you certainly could do a lot of bad things with that, but it's really nice for storing session IDs and requests and country code or something like that for every specific request. So that's a really cool Node API that came out. And people said, hey, Dino, can we have this? And so Dino will polyfill all the Node APIs, which is great because you can just use the Node APIs inside of Dino. But they're also like, well, he says, I worry a lot about adding browser incompatible APIs. Remember, it's a Node API. So what do? Well, we go to the standards bodies and say, we need something like this that will work in the browser and, of course, in all of these different JavaScript APIs. So now there is this stage 1 draft for this thing called async context. It will work very much the same way, and then it will be implemented, hopefully, in all of the other runtimes. Packages. So there's lots of packages out there, and that's kind of the whole idea behind this talk is that people are starting to write packages that don't just run in Node, but if you think about a lot of these APIs, okay, I'm going to use web streams instead of Node streams. I'm going to use the context API instead of async context API. So if you think about building your packages with APIs that are standard, then they will work everywhere. And we're starting to see, okay, well, like a big one for me was JS-DOM. JS-DOM doesn't work in a worker or in Dino or in Bun. However, people have written, there's this really nice package called LinkDOM, and they have a worker version of it, and it works in the browser. It works in a browser web worker. It works on Dino, it works on Cloudflare. It works everywhere, right? And that's really nice that you can do that. HTML rewriter. So Cloudflare invented this API called the HTML rewriter, and it's a really cool API. So this is not a standard, but everybody said that's actually pretty cool, so let's just do it ourselves. Let's implement that as well. And the way that it works is that you have a request coming in, much like I talked about the proxy version earlier, and you can write like basically query selector, jQuery-like matchers on your HTML and do little replacing. So whether that's as simple as saying, okay, well, we have the images on our application, but we don't want to serve them up from our whatever server we're paying for because that's expensive bandwidth. We want to put them on a CDN that's faster and cheaper to do that. So you could simply just intercept all those images and say any image that has a source where it's referencing /static, let's just on the fly replace it with the CDN URL that we have here. Or anywhere that I see a specific language, I could replace it. Or literally anything that is coming on in, you could replace classes. You could add dark mode to specific to things if you really wanted. There's a whole repo of worker tools. This is a really cool repo because they both have a bunch of different tools that make writing code across all of these platforms really smooth, as well as they have a whole compatibility chart of being like, where do these browser standards work at the moment? Because we're still trying to get them implemented across all of them. So check it on out if you are ever trying to implement something. Check out the worker tools repo because they have a lot of really good resources. File system. This is a bit of a weird one, is that there's no standard file system API. There's a Dino one, there's a Bun one, there's obviously the Node one. The funny thing about that is that the Node APIs work everywhere else, so the Node is kind of the standard. But there is a WGFS one, which is being looked at to possibly implement it. It's a little bit weird because like Cloudflare Workers doesn't have the concept of a file system. There's no file system. But if you are running code locally on your machine or doing like a build, then you will want that. There's so much more to this type of stuff. It's really not like a write once, work everywhere type of thing, at least not just yet. There's still certainly a lot of bumps, but that's the whole idea behind the Winter CG and all those things. It's a set of standardized APIs that allow us to create interchangeable building blocks, which is based on browser code, now runs on the server. So really what I want you to get out of this talk is when you go and build your next thing, your next worker, your next app, your next package, is build for standards as much as possible. You can polyfill them, you can get them to work, and then you'll be able to target for everywhere once you need to reach for one of these things. Thank you so much. Thank you. Oh, I'm still on. Oh, I have stickers too, by the way.
Stickers. I'll be right back. That was fantastic. It's amazing how we've gone full circle with alert. For those of you who don't know, back in the day, there was no debugger. The only way you can debug JavaScript was an alert. You had to throw it up. So every single line of code had an alert, and if you hit it, it would pop up in the browser. This is like the IE6 days. I'm dating myself now. But it's amazing that Wes has shared that we can go all the way back, full circle to Node, and now we can throw up alerts in Node. So now my team gets to hear all of my dad jokes, and they can't get away from them because it's in the code this time. They can't just ignore me on Slack. Next up is Ankita, talking about the mystery of React's re-rendering. This should be a really good talk because I really don't understand it, and I know she's going to drop a lot of knowledge. So give it up for Ankita.
Just testing my slides just to make sure everything works. So yeah, today's talk is all about unlocking the mystery of React's re-rendering, and we are going to be talking about performance a little bit as well. But first, let me ask a question. Raise your hand. How many of you think of performance from the beginning? The minute you start writing any code, you start thinking about performance. Please raise your hand. Okay, we have quite a few, which is amazing. And it also is great because a lot of you are just like me because we don't think about performance from the get-go. A lot of us think of performance as an afterthought. Once it starts to become a bottleneck, and once we get those infinite re-renders, and that's when we realize, okay, we are doing something wrong here. So when our components are slow, when our app is too slow to load, that's when we start thinking about performance in general. But that shouldn't be the case. And in this specific talk, I want to go back all the way and kind of discuss React's re-rendering patterns and how we can learn a bit of that so that we don't have to do that as an afterthought. So hello, my name is Ankita. I am currently an educator. I transitioned to being that a few months ago. But previously, I have been a senior engineering leader, worked as a solution architect developer. You can find me on YouTube and also on Twitter. But if anyone has a blue sky invite, please come find me later. Because we all know that we all want those invite codes. Yeah, but I also have a YouTube channel where I focus mainly on helping developers level up in their engineering careers. So yeah, please subscribe. That's what YouTubers say. Or I should say like and subscribe. Anyway, so here are all my slides, which you can find, and there's a barcode as well. And I also write a weekly newsletter if you want to check that out too. All right, so why does performance matter? Like, if you have to think about it, let's start from the get-go. Why does performance matter? Because the user of your app are not going to care about which library, which framework, which NPM package we geek about. They are going to care about how fast your app loads. Now, we were on a Wi-Fi network. I feel like in a huge part of the world, I feel like that is the reality. The apps won't load as fast. Images take they're too slow to load, and that is the reality for our users. And you are committing a crime when your app does not have dark mode, which is what I have learned. Anything I've deployed, the first question I get is, it doesn't work for dark mode. And so we are going to build an app to basically talk about React's re-rendering cycle. So let's build a dark mode app, and it's very simple, it's straightforward. We have a logo, which is the Dogecoin, and then there's a button there. So whenever you click on toggle dark mode, it transitions from dark to light, light to dark, and so on. And this is the architecture of an app. We have the logo, we have the dark mode, we have some text that says dark mode enabled or disabled, and we also have a footer called Anki Kobe Bean Incorporation. Now, if you want to know why that is the name of my company, please come find me later, because that will become a really good story to talk about. But yeah, that is the footer component in general. So when React captures a snapshot of this specific UI, then this is how it looks like. What React is, you need to think about like this specific snapshot, but in general, what React does is think of it like a photographer that's taking a photo of your component like DOM. It has a logo, footer, and it tries to capture in memory, this is what it looks like. So let's say that it takes a photo. And if you want to enable updates in component re-renders, which is what we will do for our app, our dark mode app, you can go to the profiler and click on highlight updates when components re-render. Because that is really important, because that is the beginning, I guess like the basics of performance in general. So what happens when I toggle that on and when I click on that in general? You can see this flash, right? Like the logo flashes, the footer flashes, and so on. That's what happens when you start profiling your app. So if we take a look at that specific code, we will see that this is how our home looks like. We have a state for dark mode and set dark mode, right? We have a logo component. We have a button with the on-click handler. And at the bottom, there's a footer. And you can see that. So I've used Tailwind for this app, but I have removed a lot of that code just to make it easier in general. So now if React were to recapture the snapshot of this UI, as the dark mode changes, then it's still like it has the footer, it has the toggle dark mode, and the logo in general. But again, it's trying to, as our dark mode state has changed, it has recaptured, it has retaken a photo, just because the state has changed. It doesn't remember anymore. So now we have 2 photos instead of 1. So what is re-rendering? Now, React's main job is to keep UI in sync with your application state, and the tool it uses is called re-rendering. So all it wants to do is doesn't want the user to see stale data. We always want to show fresh data. So that's our goal for re-rendering, right? And throughout this talk, we are going to go back to this goal as well. We want to reduce the amount of work that any of our components or our code does, but also reduce the number of re-renders in general. And with re-rendering, that's the job of re-rendering in general. And there is a common misconception that a component re-renders when the prop changes. It doesn't matter whether the component's props change or not when we talk about, in general, re-rendering of components which are not memoized. And we will talk about memoization in a second. But when a component re-renders, it tries to re-render all of its children. Well, it doesn't matter if you pass it a prop or not. The fact that the state changes in the parent component, it re-renders, which trickles down to all its children components. And I think this in itself is a huge thing when you think about performance. So yeah, this is a really good photo for that, a GIF for that. Re-renders only affect the component that owns the state, and all its children if it's any. So when a component re-renders, it re-renders all its children. And we don't want React to re-render when it's not needed. That's something that we don't want, as we discussed in our goals as well. But why does it happen? Like, how can we prevent that from happening? So let's talk about how React works in general, right? So application state changes, then it triggers the re-rendering. For example, photos are being taken by the re-rendering tool, and it re-renders, all the children gets re-rendered, and your view gets updated. And that is exactly what React does. And along the way, it decides, should it re-render, should it not? What are things that we can do to help that? So again, React's main job is to keep the application UI in sync with the state, and the point of it is to figure out what needs to change and why. So if you profile our little app again, and you can click on that icon in the Profiler tab to start profiling it, you can see that, for example, the logo component over there is something that does get re-rendered, right? Logo re-renders when it should not, and same for footer as well, because they are the children of the home page that we saw. So you can see how long it takes, and it re-renders. It's going to re-render every time dark mode changes. But in reality, we don't want that, right? We don't want our logo or footer or components that are pure. Whenever we give it an input, it's the same output over and over. We don't want that in general. So how do we solve for this? Well, how do we solve for the logo component to avoid re-rendering in general? So what we can do is we can wrap logo and footer in memo, and this will allow it to memoize the component in general. So React knows that it doesn't need to re-render. It's going to just, the same photographer that we talked about, it's not going to click a new photo. It's just going to give you an existing photo. Like, hey, I have this photo. Let me take this, because it doesn't need to, unless there is some state and prop that changes. So that's where memoization comes in, and that we just took a look at that. You know, hey, I know this component is pure. You don't need to re-render, right? And that is the idea of memoization. I kind of think of memoization because I've done like full stack development as caching as well, right? It caches the data, and we tell it, hey, change it or not. So if you profile a little app again, as we added the memo code, right, you can see that it doesn't flash anymore, because even though we are changing the toggle dark mode, right? And that's the thing with it. And if we pause that specific GIF that we looked at, you can see that there is no footer nor logo when we profile our app as well. And again, as you start building these components, I think what's important is that you start profiling it. Don't wait for towards the end, or like when you're starting to deploy your application to production. Make this as part of your code review process and ask these questions if this is something that's needed or not. So now let's move our dark mode logic that we saw. It was quite messy in there, right? I had a handler code inline as well. I had the state inside. But in the future, I do want to use dark mode, because as we saw, we don't want to commit a crime. We want dark mode to be used in other apps and as well. So let's create a hook. We all like custom hooks, so let's do that. Let's call it dark mode. And the part that I want to highlight here is, here we are returning the dark mode and handle toggle function. But notice that I have wrapped it inside a use callback, a hook that's available for us so that we can, again, tell to not specifically cache that, to basically cache the specific function. And for example, use callback in this case will cache functions. It will return the cache function, and then that dependency array is very important right there, because what it's going to do is we're saying is, hey, you can purge the cache if the dependency changes. Otherwise, just keep giving me the same function over and over. And that's the whole point of use callback. So again, going back to our specific hook again, you can see that dark mode, but we only want that specific function to change when the dark mode dependency array changes, right? And that's why we have wrapped it inside a use callback. Now, do you necessarily want to, like, how many times are we going to change dark mode or not? But in this case, this hook is going to be used in a lot of different applications, and I want it to be as performant as possible. So, for example, going back to use callback, if we didn't do that, we will have the same function but different copies, right? A brand new function on every single re-render. And we don't want millions of set toggle. Maybe it's being a bit dramatic, not millions, but many functions in general. So depending on the dependencies, we only want to change or give it the same copy. And again, use memo is also something that we use in general with use callback. And again, it caches things, and we'll talk about things in general. But it returns the cached value. And again, the same dependency array is used to decide if you want to purge cache or not. And this is the code for it. I know it looks scary. I wanted to reduce it. It's very simple, and this is just for example's sake. So for example, we have the color, set color, and color as states. And then there's a very expensive computation right here. And what we're saying is, whenever color changes, run the expensive computation. Now, with use memo, this function will only run when the state color changes. But imagine we didn't have that, right? We did not wrap it inside use memo. There's no dependency array. That means every time the component re-renders, this expensive computation is going to run. And we really don't want that. So that's why we are depending on the dependency array, and we are depending on it, and we're sharing it like, hey, don't change it. So again, that's the whole point of use memo in general as well. And I want to also take a quick break here as well, so because I'm launching a course and a program in general, which is called Developer to Leader. So this is a program that helps developers transition into engineering leadership. So if you're interested to become a leader or see it in the future, then definitely check it out. And yeah, so this is the barcode for it, and it's developerleader.com. And yeah, it's really fun. A lot of, I guess, 30 or so people have signed up already. And if you're interested, come find me later as well and ask me any questions you may have. So going back to performance steps. So what you want to do is you want to test it on every single device and network. Now, again, a lot of us have really high-speed internet that doesn't represent our users, right? For example, we saw that at least the Wi-Fi was a little bit slower than usual. Suddenly, I started noticing that how my websites are performing. In fact, developer to leader, I was like, I need to cache more things. I'm going to take a look at it and see what are more caching that I can do on that website. Because there are certain things that were really slowly loading. So what you want to focus on here is that you want to test on low-end devices. You want to test on slower networks and throttle. And in Chrome, you can do that in developer tools. Test out on different slower networks and slow on, and throttle it. And lastly, profile your app on production mode, not just development mode. Why? Because in development mode, we have a lot of things enabled in general that in production mode, that's not the reality. So you want to test on both. But as you start to scale your application, you want to think about these things in general. Personally, I would also just do it as part of every feature or every user story in general that you take on. But I also want you to remember that you don't want to fix what's not broken, because React is also really performant out of the box. We don't need to do a lot, but as you start building and as you start building these components and as you start getting more aware about it, that's when you need to start thinking about it. But again, let's remember our goal with re-rendering, right? We want to reduce the amount of work. We want to reduce the number of re-renders, and that is like our formula, right? So in this case, should you use memo and use callback everywhere, right? We talked about we want to memorize everything. We want to cache everything as much as possible, right? But use memo is only valuable in a few cases. Now, one of them being the calculation that you're putting in use memo is noticeably slow, and the dependencies rarely change. So again, it goes back to the dependency array that we talked about. Another method that I would recommend using, and if you're not sure if a function is slow or not, or if there are certain things that you need to profile better, then you want to maybe also use console.time or timer to test out exactly how fast your function is. So again, you want to make sure that what you add in the dependency array is really important. But you don't want to wrap every single function in general with use memo and use callback. So how do we do this for hundreds of apps, right? Hundreds of components in general. Because we just talked about dark mode, which is a very simple, straightforward example. But you can think of it like a very good basic example, which does cover a lot of use cases, right? But as I said, you want to start with the profiler, start profiling your apps, Start measuring the performance of your components. Start building that awareness in your team in general. Make it part of your code reviews, and overall, look at your architecture. And during code reviews, you want to ask, should we wrap this function inside use callback? Do we need it cached or not? How much it's going to change, and so on. And lastly, what's really important here is that, for example, sometimes it's easier for React to re-render with many props. In this case, for example, a card component. And I'm not saying that you should not wrap any of the card component with use callback or use memo or whatsoever. What I'm saying is that sometimes when you have a lot of different props, if you go back to React's job of to figure out re-rendering or not, what you want to think of is, should we wrap every function or memoize everything? Because what React is going to do, or the re-rendering tool that we looked at, it's going to compare, right? What has changed, what has not. And the fact that we do it over and over every single time, sometimes it's a lot easier for it to just re-render, right? And going back to the photographer example that we said, let it take as many photos as it wants, because this component is more expensive to memoize each and everything and for it to compare, because it's going to be a lot more work, and then figuring out the dependency change versus in general. So card component is a good example of that. It is very complex, right? Like if you think about card component, this is a very simple example, but we have different color properties in this product for lipstick, and let's say this is an e-commerce application. Then in general, you have a lot of different props with the photo, with the description. You want to make sure that this specific product tile renders in the right sense, and there are a lot of handlers in general, accessibility props and whatnot that you want to think of. So when it comes to a complex component, really try to assess if it's worth it based on the dependencies, and if it's how much time does it take, and profile it every single time, because you want to do that as part of your job. And lastly, Lighthouse doesn't really represent performance, because React is performant out of the box. But in general, that's the first step you should do, right? You should go to Lighthouse and check your performance score. But if Lighthouse says it's 99, does that mean that it is really performant, right? Does that mean that you don't need to worry about it in general? Not really, right? Because 99 in Lighthouse is basically an average that they take just to understand, okay, on average, how much time it would take to measure the performance of an app, but it doesn't really represent production. You still need to do all these different practices, and Lighthouse can be the first step, but there are many more steps that we talked about in this specific talk that you want to do as part of your performance. So again, like building that awareness really helps. And Lighthouse, I know that there's work being done, as I was talking to a couple of speakers, that where they are adding some properties to change a lot of this, and we can learn more about our performance in general. But again, that's great, but you still want to be doing all these things that we talked about, because again, that's a good cherry on the cake. So yeah, that's it from me. Thank you so much for checking out this talk. And yeah, go to developer2leader.com if you're interested, and all my slides are here. Thank you so much.
Great, thank you. That was awesome. I don't know about you all, but when React released a lot of these hooks, they were sort of seemingly obscure to me, at least. And it's great to have kind of a rundown of some of these things that puts the performance of our applications back into our hands, as opposed to sort of just handing it over to React, especially as we build larger and larger single-page applications. So anyways, on to our next talk. Please give a welcome to Andre.
Hey everyone, give me a hands up if you believe that React is awesome. You heard about use memo, use effect maybe, yeah? A lot of hands, good, good. I picked up React a few months before hooks were introduced, and React has changed, right? And I feel like the same thing is happening now with React Server Components, where there's still a lot of questions. I remember reading this blog post by Wes Boss about the context API when hooks were first introduced. And yeah, it feels very similar right now, right? Like, a lot of question marks, how will we use React Server Components? The React documentation is now ready recommending us to use Next.js and Remix and other full-stack web frameworks to really take advantage of React as an architecture. So React is not only a library anymore, but also something that you have to implement. You need a compiler and a router and different pieces to work together for that. So very interesting to see how React is taking over more and more parts of our stack and embracing the server environment. Yesterday it was already said, right? Jeff mentioned it, I think. There's no one-size-fits-all solution, and probably there will never be one. So if you're comfortable in your current stack, that's all good. But if you're excited about Remix, if you're excited about Next.js, if you're curious about React Server Component, I believe there's a really good time right now to go full stack. And my name is Andre. I'm a developer from Germany. I work here in Cupertino for LinkedIn, and I'm really excited, and I love building for the web. And I've never had a better experience building for the web than with Next.js and Remix and really taking advantage of the full stack of the web platform. So the type inference you get, right, like across the network boundaries, the co-location of client and server code. And it ships with all these things that I don't want to mess with. I don't even know which compiler Next.js is using right now. Maybe you know. It just works out of the box, right, and it's super fast. It's very convenient to use. And we heard from Wes, right, the edge, serverless, oops, it's falling out. Long-running servers, right, there's so many cool environments that we can take advantage of if we have access to a full-stack web framework. So it's really exciting because we get all of this out of the box. So if you go back to work tomorrow and you want to explain that excitement to your boss, right, and you're like, we should try out Next.js for our next cool project, or for our big migration, let's use Remix, right? And your boss is like, oh, why? And you're like, a type inference and a React server boundaries and suspense. You know, like, that might not be the right language to communicate to non-technical stakeholders, right? So maybe you have to put on your business hat and convert your excitement into something that your boss also understands. And that's usually a business case. Cool. So there's a lot of different angles you could take to kind of convey a business case, right? You could certainly talk about developer experience and developer productivity, and you could make a case about these things. But I think it's way easier to talk about web performance, right? That's the motto of Reactathon this year. We have the web vitals. We know that they exist. Everybody knows about Lighthouse. It's easy to argue this way. There's also already analytics at place at your company, right? You're all measuring the speed index or largest contentful paint. So it's easier to run A/B tests this way. And most importantly, it's easier to translate web vitals into business metrics. There's so many cool studies already out there that kind of prove that if you improve web vitals, that it impacts revenue, drop-off rates, conversions, and whatnot. So it's easier to make a business case out of this. Cool. Obviously, a performance-based business case heavily depends on your own org structure, your team capabilities, and your tech stack, right? A business case is nothing I can just give you and you use. A business case is something you have to build at your own company. So everything we talk about here today is very theoretical. All the images, by the way, are generated by AI, so don't look too closely. Yeah, so this is all very theoretical, and it starts with you. So in your company, you invent the business case, and it slowly triples upwards, bubbles upwards, and you have to convince your team, your manager, and then maybe upper and upper leadership. At LinkedIn, we have a manager of a manager of a manager of a manager, right? And at some point, you need a final thumbs up, and for that, you probably have to already provide an A/B test and show that really something impacted the revenue so that you get approval. At smaller companies, if you have a flatmate and you run a startup, it might be easier. Anyways, in each of these levels, you have to provide different arguments, right? You need different numbers, different proofs. I hope this talk helps you to get initial buy-in. So if you're interested in going full stack, then maybe this talk, the arguments I'm giving you, helps you to convince your boss so you can take some time out of your day to invest in building an MVP using Next.js or Remix. Cool. So in this theoretical business case, what we will be comparing is a client-side only SPA, something like Create React App, something that runs on a CDN. We have heard a lot of these comparisons yesterday already. So we own this. We are the front-end team, right? There's a back-end team. We are the front-end team. We only run on the client right now on the browser runtime, and we make API requests to third-party servers, right? So maybe it's our own company, like it's Carl, the Java guy. It might be a different team. It might be 10 different teams. But it's not us. We are the front-end team. We consume that kind of stuff, and our control zone right now is only the browser environment. So that also means we don't have direct control over the web performance, because that web performance really depends on these APIs. If they don't implement pagination, then maybe our performance suffers, right? Cool. So that's why we want to migrate. That's the business case that we're trying to build. We want to have more control. And Next.js and Remix are good examples for that, but obviously you can also build your own framework or use any other SvelteKit. There's so many, right? And what happens now is if we use one of these frameworks, we have access to the HTTP request for document and data requests, and we run on both the server and the client, and we own the full stack of the web platform. That sounds very PHP, but yeah, we own the web server again. So that's what we gain, the web server and the tool of the web server, right? Cool, so I built a demo app for this, just 80 movies in a grid, and I did this very much for Reactathon. It's a very conference-driven business case, and I ran a lot of lab tests, and we just heard already, right, lab test is just a start. It's not really what performance is about, but it's a good start. And I did a lot of tests and even more tests on render.com and Vercel, serverless, edge, and long-running servers using Next.js and Remix and React server components. Yeah, and they performed very well compared to the client-side SPAs. And if you want to see the actual business case and the raw data, there's the QR code to that, and maybe you can convince your manager to get initial buy-in. But what I want to talk about right now actually is the 7 ideas I used to iteratively improve the performance of my full-stack web app. So over time, I used more tools of the server and more tools of the server to make it more performant. So if you're already on Next.js or Remix, or you have already access to a server environment, maybe those tools help you as well. And if you want to migrate, maybe that's something you can add to your business case. What all of these 7 steps have in common is that we take access and advantage of the server environment. Cool, we start with server-side rendering. We have heard all about that and React 18 streaming already yesterday. But if we only server-side render without server-side data fetching, effectively what we do is server-side render our spinners. So it doesn't get us far. It's not bad. You can see the performance is the same as the SPA for my lab tests. But it really starts like showing some advancements if we add and move our data fetching to the server as well. Cool. So what happens if we fetch our data fetching to the server is that we use our backend of our web platform as a proxy, right, as the backend for our front end. We still don't have access to the third-party APIs. We don't query the database directly. There are still backend teams, but we as the front-end team now have our own backend that is between us and the third-party APIs. So we own now the control of the web performance because everything goes through our proxy. So we fetch the data on our backend and forward it to our client during server-side rendering or during the data, like subsequent data requests. And what happens if we do this is, first of all, we get rid of the spinners because we server-side render the content with all the data that is already there, and we forward it to the client. But what we also do is avoid a lot of round trips. So if you have a client-side only SPA, you have to first download the HTML, then you have to download the JavaScript, most likely both from the CDN, and then you can start doing data fetching, right, with React Query or something. So it's 2 round trips to the CDN and then an additional round trip to get the data from the REST API server or whatnot. And if you have a full-stack web app, what we do is 1 round trip to the server where we start fetching the data. And once that is done, we download the document, and we got all the data, and the largest contentful paint can already start, right? We can start downloading the images and whatnot. So it's 1 versus 3 round trips for the largest contentful paint. Yes, we still have to fetch the data, but those are server-to-server requests, which are usually way faster, right? They might stay in the same data center. Just improve performance. For interactivity, we still need to download the JavaScript, but we're not blocked by that, and that is great. But what I'm most excited about is once we have access to the server environment and we do data fetching there, right, we can use it as a proxy and really own whatever we return and forward to the client. For instance, we can avoid overfetching by filtering out data. So this is like an example movie component to show one of these movies on the page for my demo app. But the third-party API I used to fetch the movies returned a lot of fields I never used. So I download them unnecessarily, right? Like it's just wasted kilobytes of data. So for 80 movies, that's like 15 kilobytes versus 3 kilobytes, so we can save 12 kilobytes. Obviously, it heavily depends on the data and the compression you use, right? But just showcasing that if you avoid overfetching, you can really speed up performance by downloading less data. You might say, no, well, I use GraphQL, and that already fixes it. And yes, GraphQL avoids overfetching, and GraphQL is great for orchestration and whatnot as well. But if you use GraphQL on the client, those libraries are kind of heavy. So it's the first and then the second that you would need for Apollo, right? So you would kind of negate the advancements you have with avoidance of overfetching. So again, instead, I would say move libraries to the server instead. right? For all of your dependencies, if you build a business case, you can go through them and say, like, this is validation related, this is data fetching related, this is aggregation related, and maybe you can only run them on the initial page load, and you avoid including them in your client bundle, right? And you can have only these tools if you have access to the server. GraphQL, for instance, just a proposal, I don't know if this actually works, but maybe move it to your Next.js, get server-side props, and use GraphQL as an orchestration layer only on the server, not on the client, right? And then you avoid downloading it. Cool. Similarly, you can move your own JavaScript to the server. This function filters out adult movies, because I built a family-friendly demo. You can move this filter function down to the client, right? Or you run it on the server. If you run it on the client, you overfetch data that you never display, and you have to download the filter function to execute. If you only run it on the server during initial page load, like in your Remix loaders, you avoid downloading that module altogether, right? With smart tree shaking, it's not included in your client bundle anymore. So for all of your big modules, right, like if you move them to the server, you might be able to avoid more overfetching and ship less JavaScript. So for your business case, it's something you could think about. Cool. I'm getting repetitive, but stick with me. This is, I'm trying to prove a point here. We can move heavy computations to the server. Because usually your AWS service is way more powerful than your user's device, right? So it speeded up stuff. Also, you avoid draining your user's batteries if you use a server for heavy computations. But the reason I included this is because it always depends, right? Like, it depends on your use case. Sometimes it makes a lot of sense to do stuff on the client. Sometimes it makes a lot of sense to do stuff on the server. But the great thing about today's full-stack web frameworks is that we have access to all the tools of the client and all the tools of the server. Nobody is taking the client away from you, right? It's just more tools that we can choose from to make the right trade-offs. That's why I'm so excited about Remix and why I'm so excited about Next.js. Cool. And really to drive this point home, caching, something you can only really do if you have access to a server environment. And if your APIs are slow and you're not the priority of the API endpoints because it's a third-party company and they have a lot of consumers and you're just one of them, then maybe with a full-stack web framework, you can do the caching and own it, right, and really improve the performance for your application. There's a lot of ways you can do caching with HTTP headers, in memory on the server if you have a long-running server, or you use a service like Redis. And for my movie app, I actually had to do 2 requests to start downloading the images. So I had to download this movies config object and all the movies from the database, from the API. And then I was able to construct the image source. So it's this like base URL and some like config data that I needed for each image. So it's a request waterfall, which is fine because we have to download the movies anyway. And usually this is also fine because we can make both requests in parallel, and then we await the data, and usually they arrive at the same time, or the movies config is faster because the movies are the bigger payload anyways. But when it really gets annoying is if the movies config, this like very static object that never changes, decides to take a little adventure on the internet and takes the scenic route, and now we are blocked by this like very static thing that we could potentially hard code in our app, right? So if you have a client-side SPA and you realize there's something that is never really changing, what are your options? You fetch it on every initial request, or you hard code it in your code, right? Like, it's 2 bad options because you don't have all the tools that you could possibly need for the job. So that's why it's so cool to have access to the server and the tools of the server, because in this case, we can use caching, right? Movies config is the same for all users. It never really changes, so we can easily add some caching headers there, cache it in a CDN, and avoid making the request altogether. And if you combine all these things together, right, what do we do? Avoid overfetching, you need a server environment, server-side rendering, server-side data fetching, caching, move computations maybe there. Like, if you about all your features think, where can I run this? Which is the best tool to use for this job or for this feature, right? I'm pretty sure you can also improve the performance of your apps. Obviously, not one-size-fits-all solution, but more tools are usually better. And then if you tie this back to the already existing studies, and if you go to vpostats.com, I'm very certain you will find some studies about your own industries. I'm pretty sure you will be able to build a solid business case. And yeah, remember, it all starts with you, because it bubbles upwards, and once you're excited, you can excite your team, and once your team is excited, maybe the manager gets excited, and we slowly take it from there. And yeah, in the future, hopefully we all use React Server components. Cool. Thanks so much.
Great talk, Andre. Don't tell anybody, but I'm actually an engineering manager, not a software engineer. I snuck in here. So that part about having a good business case really resonates with me. So we learned a lot this morning. Now it's time to take a break. Let's come back at 11:45. Go down, mingle, make some friends. Remember Pac-Man, join people in your group, breed badges, and I'll see you soon for the next block of talks.
I was running to the ocean. I didn't wanna be tied down to nothing. But since I met you, I didn't know it. That underneath it all, you started something. On a Saturday night, Keep watching you when you leave. Something new. Keep hoping you feel this too. Holding on and on and on and on. Hoping I can get to know you better. Living in sweet suburbia. Some fun is all we want. Two kids come alive in a night rush. I'll be the girl next door. You be my summer crush. Yeah, I think you should come and pick me up. 'Cause nothing feels as good as summer love. Move so fast. Here's hoping this night will last. Just let go. We're spinning with our eyes closed. Holding on and on and on and on. Hoping I can get to know you better. Living in sweet suburbia. Some fun is all we want. Two kids come alive in a night rush. I'll be the girl next door. You be my summer crush. Yeah, I think you should come and pick me up. 'Cause nothing feels as good as summer rotate to you again. I'll live the rest of my life by your side. I wanna stay here forever, playing it all like the radio. Don't see how it could be better. All I know is don't let go. Stuck in your head, rush about it. Rusted and fast with moving slow. I don't know how we found it. Something supernatural. The space between us feels like home. I feel like home wherever we go. The space between us is a place to rest your bones. It feels like home. It's supernatural. One look in your eyes and I find it. When you leave in my mind, I rewind it. When you got it this good, you don't fight it. When you're with me, nothing else matters. On gray days, I live in your laughter. I collide with your heart. I'm seeing stars. I let go of the past. I know this too shall last. Now I've been waiting all day to let you know that I wanna stay here forever, playing it all like the don't let go. Stuck in the forest. For the trees I'm keeping watch. All that is storming. Waking up and turning on. Keeping the light on. Righting all the wrongs. Keeping our sights on everything we want. We catch our breath in the middle of it all. Chasing echoes. Sun is coming up over the rest is coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all around. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see it on the horizon all around us. We can feel it. It's all we
Everyone, welcome back. How was the break? Thank you. Thank you. Did you make some new friends? Yes? Okay. One person. I think we can do a little bit better than that, but, you know, I know it's awkward meeting people. Do the best you can. I do have a dad joke for you all, and because everybody else hasn't come back yet, you are the first to hear it, you lucky group. It's actually about health. I've really been trying to get my team to eat more grapes. Like, I've been trying to get them to see the benefits of eating dried grapes, really. But really, I'm just trying to get them to see raisin. But they just can't see it. Thank you, thank you, thank you. You all are great. Everybody coming in just missed that amazing joke. Actually, can you help me play a trick on people? I'll wait for a big group, but when I say go, just give it like a really big laugh, like I just said the funniest thing you've ever heard in your life. Okay, I'm gonna wait for them to file in a little bit. Then we're all gonna have a little bit of a laugh. Well, okay. Ready? Remember, big laugh, like really, really big laugh. 1, 2, 3. Oh, thank you for that. Oh, all the people coming in now just missed probably the best joke I've ever told in my life. I have a few announcements. One, thank you to all the staff and volunteers and the people cooking the food. Conferences are a lot of work, and we really can't do it without them. All the hidden crew. Can we give them a round of applause for all the people doing work? Next, I want to call out that the volunteers and the people who help cook the food is by a company called Lifted Plates. It is a family-run catering company. If you want to have them for your next event, just ping Ben in the Reactathon Slack. And thank you to this beautiful venue. Like, wow. Have you ever been in a conference in a place this gorgeous? It's amazing. The people that are watching on YouTube, you can't see it. Maybe you can pan up, but it is incredible to stand here, and what a fantastic place to be on stage and give a talk. The AV team that is helping out, they are on top of things. They're keeping the show running. That is Argus HD. It's a community event. They're running a skeleton crew because the budget, due to the economy, it's a tight budget this year. They are doing phenomenally. I really, props to them. And the camera, one more. Camera person in the back, I didn't see you. I like calling out camera people because they don't like the attention, which is ironic, because they're always like, no, not me, I'm doing my job. And Ben also mentioned that the Wi-Fi network has been reset, so hopefully it's working. Is it working for you all now? Yes? Maybe? Okay. Well, the next talk is by Simon. It is on type safety, something people like to argue about a lot, but is really important when you're writing large-scale web applications. So give it up for Simon.
Hi, everyone. Thanks for coming. We're going to talk about type safety we're going to nerd out for the next 22 minutes on specifically about TypeScript. So I'm assuming, most folks in the React community use TypeScript. I think most folks doing any sort of JavaScript these days are using TypeScript, and we like it, right? I mean, we get confidence in our code. We get really cool autocomplete in our editor. We can refactor without too much concern, and we get fewer runtime exceptions, or that's the goal, right? In summary, we as developers, as JavaScript developers, we never want to see this again, right? That's the dream anyway, right? We never see this particular, exception in our console or anything, right? And any runtime exceptions, that's the dream. However, TypeScript is not really type safe. I mean, it has it gives some type safety, but it's not like properly type safe. It's not sound. It's not a sound type system. So it doesn't exactly deliver on the dream that we never have to see this again. And if you've done any amount of TypeScript, you kind of know what I'm talking about, right? You're still going to see some runtime exceptions. So, you know, you might think to yourself, well, that's because, you know, developers are using these unsafe features or the escape hatches. But like I would, you know, and I'll show you an example here that even with the strictest options, and even if you don't use any of the kind of unsafe escape hatches, it's still not a sound type system, right? And I'll show you an example here, right? So here we have an array of strings, and you know we don't really need that type annotation because TypeScript can trivially infer that that is an array of strings. But and then next we have an array with a broader, you know, that can accept string or number, right? And so we're going to put the array of strings into the array that can absolutely accept strings, right? Now, some of you might, if you've been doing TypeScript for a while, might know that this is unsafe, but your hint would be this. So, of course, JavaScript arrays are mutable in JavaScript. So what happens if we put a number in there? It's going to go into both arrays, right? By which I mean there's really only one array here, right? But now we have a number in our string array. And this is, you know, you might think, okay, this is an edge case, and you know, maybe it's not that big of a deal, and that's kind of true. But it illustrates, or you know, I use that example to illustrate a fundamental design choice with TypeScript, which is that TypeScript chooses to be pragmatic over being sound, right? TypeScript in general is just like, look, let's get some type safety, which is better than zero type safety, and let's make it fun to use and a good developer experience, and we're not going to worry too much about all the edge cases, right? And I think that's fine. In fact, I think it was largely I think a lot of TypeScript's success, especially early on, was because of this principle, right? Which is that, hey, we're not going to be perfect, but we're going to be good enough, and it's going to be fun to use, right? So being pragmatic. But this talk is about type safety. So what we want to do, especially considering it's been like a decade since TypeScript has been around, it's been over a decade, and you know the ecosystem has changed, and we want more type safety now, right? So we're going to talk today about how can we maximize type safety with TypeScript? Like, what can we do to get better type safety? And why would we want to do that? Kind of for the same reasons that we saw earlier, right? In particular, because we just don't want runtime exceptions, right? We don't want to find out in production that our code doesn't work. Okay, so where does TypeScript fall short? Some of you probably already know where it falls short or where the kind of gaps in TypeScript are, but it's not null safe, at least not by default. You have to you can squeeze some null safety out of it, but there's tons of ways to disable type checking, right? Any is the obvious one. There's like type assertions. There's all kinds of things. And then, of course, like TypeScript doesn't have any knowledge about data coming from outside of your code, right? Because TypeScript disappears at runtime. And so it only knows about what's in your code at compile time. There's no built-in mechanisms for, you know, validation. And so, and there's a few unsafe defaults. And so we're going to look at some of these today. But we're also going to look at what can we do to get better type safety out of it. So there's, broadly speaking, 4 things that we can do as developers, right? Because I mean, we can't change the language unless we want to make a pull request to TypeScript. But what can we do? We can make sure that we have stricter config, and you know, we can mess with our TS config a bit. We can add some lint rules to prevent us from doing some bad things. We can do some stuff with global types that I'll show you in a moment, and then kind of the big one is what can we do with the I/O boundaries? What can we do with data that comes from the outside world? So we're going to first kind of look at what I would consider to be a little bit of the low-hanging fruit. That's kind of the first 3, right? And I'll show you how, like, these are not much effort, especially on greenfield projects. They're kind of a no-brainer. So stricter config. So we're going to talk about these 2 rules. In fact, these are the only 2 rules that I care that you have in your TS config. Like, you got to have these. Strict. We're going to start with strict, and I would assume that most of you have that. So, like, the official definition is, like, turning on strict is equivalent to enabling all of the, like, strict mode family of options. And I'm sure most projects have that. It didn't used to be the default. It now is. What are the family of options? It's like all this stuff that you kind of don't need to care about, other than to know that it's not on by default in some projects. But, like, this is kind of legacy stuff from when TypeScript was a lot less strict. It was a lot looser. So you want to turn that on. Strict is true. And then the other one that you want to turn on is no unchecked index access, which is relatively new. I mean, it's 2 or 3 years old now, but it's sadly not on in a lot of code bases. And I'll use someone else's words to describe it, which is the no unchecked index access is the most awesome config option you've never heard of, right? Which is unfortunate, but it is really useful. And I'll show you a couple of examples why you want to turn this strictness rule on in your TS config. So many of you would look at this and you would know that this is going to blow up in runtime, right? This code's not going to work. But TypeScript, by default, will be like, yep, that checks out. You got an array of strings, and you can call 2 uppercase on a string. No issue there, right? You know, and the object variant of it is this. Like, here's an object that has like keys that are strings and values that are strings. I just want to grab some arbitrary property and call 2 uppercase on it. TypeScript's like, yep, that checks out. There's strings in this object for sure. Of course, this will blow up. So you got to turn on your. So you turn on that option. Both of these will be an error, right? Because it'll say params that username might be undefined, which it might. Interestingly, like anecdotally, this is like real code from a real code base that I was reviewing, and so like the top line is what the coder put, and I was like, why would you put filter and then just grab the first element when we have find? And they were like, oh, because find might return undefined, but the first one will never return undefined. I think that will return undefined. So what happens is, like, because it's not type safe, or because it's not strict enough, people lean on that, like, lean on those loopholes, I guess you'd call them, right? So anyway, turn on your, make your TS config stricter, and you won't run into situations like this. So, okay, lint rules. Why are we talking about lint? Because TypeScript has escape hatches, and it's good that TypeScript has escape hatches. We need them sometimes, but we want to make lint kind of yell at us if we do. So we want to make it so we have to explicitly kind of opt into using an escape hatch. So we want to, okay, we have to like ESLint disable if we want to use this escape hatch. What am I talking about? Typically any. So like you should probably have a lint rule that says just don't use any. And then the times when you really need to use it, you can just explicitly turn off that lint rule for that line. Type assertions as is probably a more controversial one, but generally speaking, you shouldn't use the word as unless you're a library author, or unless you're writing the word as const, which is great. But any other use of the word as, let's skip it. Non-null assertions, you may not know about this one. It's a little bit like unusual, and if you don't know about it, great, because you probably shouldn't use it. And then the last one is that you can write a function and type it as just function with a capital F, which is like not type safe. So anyway, these are things that like you probably don't use the bottom two, and you shouldn't. And we should disable them, and we should use lint to do that, right? So we have TypeScript ESLint, and it's great. And all you have to do is say, let's just use the recommended rule set. And if you're brave, use the strict rule set, and you'll be good. And then you'll get this, right? So you'll try to use any, and it'll say, no, you shouldn't do that. And sometimes I love the wording, it's like specify a different type. Okay, so that's kind of the first two. Like I said, easy, just configure some things, recommended lint config, you're good to go. Global types, so this is an interesting one. So as many of you probably know, if you do JSON.parse, it's going to give you back a type called any. And so this actually illustrates that even if you make a lint rule that says you can't use the word any, any's will creep into your code, as you probably know. And so in this case, it's just going to let us call random methods and properties and things on there because it's any. So what we really want is we want that to be typed as the better variant of any, which is unknown. And so how do we do it? Well, sadly, the built-in JSON.parse definition, like the type def for that built-in function is kind of looser than we'd like, and so we want more type safety. So you go into your global.t.ts, global.d.ts, and you fix it, and you write up, you augment the built-in type defs. It kind of sucks, but it's one line. You got to do it once, in your code base, and you're done with it. And then kind of similarly, the array example. So array.isArray, it says, okay, cool, here's an array, but an array of what? It's an array of any, so it lets you do all kinds of funky things on that, which again, you probably just want to go in here and just say, okay, well, I want this to be an array of unknown, so I can't do anything bad with that. But again, like this list is going to grow now, right? So there's a few more of these, and it kind of sucks. Like, do I have to like paste some magic global d.ts if I want type safety? And luckily, the answer is that you don't have to. So you can go out on NPM and you can pull in TS reset, which is relatively new, and it's kind of awesome, and it just does that for you. It's like, hey, here's a better set of defaults for your types. So again, like community to the rescue, we don't have to do as much of the legwork there. So what do we get then? It says, okay, well, result is of type unknown, because sure it is, right? Like we parsed it from who knows what. There's no guarantees about what is or isn't in that data type, right? Okay. So now we get to the harder stuff. So that's relatively easy. It's like pull in an npm package, configure your tsconfig. But what about like kind of the I/O boundaries, which is, I guess, to be more specific about what I mean by this is anything that comes in from the outside world to your code, or to put it in another way, anything that TypeScript can't infer at compile time or can't know about at compile time because, it doesn't exist at compile time, right? So stuff that's coming from the database, anything that's coming from, an API, a server, request response stuff, user input, so like CLI args is kind of an interesting one, query params. Really anything that gets parsed from JSON, you're gonna see a theme here. There's a lot of like JSON stuff coming into play. But if you use, so on the database point, if you use Prisma or some kind of like type-safe database system, you probably don't have to worry about that. But if you're writing SQL, TypeScript can't really inspect your SQL query and have any clue what's gonna come out of there, right? Okay, so what do we do about this stuff? Well, here's like a, I guess, simple example right off Express's, kind of getting started or whatever. The idea is that you get this thing called request.body. It has some sort of user input, like presumably some user out in the internet sent you this data. But this would not be like TypeScript will allow this. It'll be like, sure, okay, request.body has some data. We don't know what, it'll be any. And you can just grab the title, the content. But in reality, we didn't validate anything. And there's a lot of code out there like this. And it's just kind of, it's not a flaw in TypeScript. It's just TypeScript can't know about this stuff, right? Okay, I mean, that's probably basic. You all kind of know that stuff. But what is the solution? So the solution is we just want to use a validation library. And so like this is a really good one, right? This is kind of the hot one in the TypeScript community these days. How does it work? You specify a schema and you say, okay, my request body will have or needs to have these two fields. This is a string. This is like, you put optional things in there. You can nest objects. You can kind of describe anything you can in TypeScript, but you describe it using this kind of like DSL, this kind of language that will then create a like a validator for you, right? Validators aren't new, but Zod is a really good one. So what do you do with it? You're kind of forced to parse the request body before you can do anything useful, right? So if we didn't have, so here, we're gonna essentially validate. It's called safe parse, but we're essentially gonna validate the body before we can do anything. And then this block here, we need to have that. So if we don't have that, TypeScript will complain. So it forces us to have this. And in this case, we're just gonna send a 400 or whatever, right? So that generally falls under the category of schema-based validation. And essentially, Zod is the solution to a lot of what we saw on the kind of I/O boundary slide, right? Like most of that stuff can be solved with just writing a schema and validating some data from, the user, the network, what have you, right? Okay, so now we're going to look at like a slightly different manifestation of roughly the same problem, which is the fetch problem, right? So now we're on the client and we're saying, okay, well, I got to fetch some data. We're going to get movies and, we'll parse it into JSON. And again, like TypeScript's going to say, well, I don't know what data came back, so I'll let you do whatever you want without any type checking, no auto-completion, nothing. And unless you install TS reset, in which case you're going to get a complaint here saying data is of type unknown, which is correct, it is unknown. But what is the solution here? Like what are we supposed to do in this situation? And I don't know that there is like one solution, but typically what you'll see is you'll see a type assertion. Someone will just say as. And I know I said earlier as is bad, and it kind of is, but this is a case where we may not have that much of a better option, so typically you'll see people use a type assertion here. But I am going to show you a better option. And what we should probably do here is, so here we've essentially written the type. We've said, okay, response body is of type object with a property called movies, and that's an array, and then presumably we have this movie type somewhere, but we had to write all that, unless we got lucky and our server system provided it or something. But what we probably really want to do is generate it. Like we don't want to write all those types. So you could pull, again, community to the rescue here, pull in something from the community, generate your types. It's a little boilerplatey, so you end up having to say, okay, here's my generated schema. Now I got to, out of that like huge generated thing, I got to pull out, okay, the movies endpoint, the get request, I want the 200 response, the JSON, like, but so at least it's type safe, right? So if you misspell one of these things or if you put the wrong endpoint, it's going to complain at you. So it's type safe, you get your response body, and then you can do your type assertion. But there's no validation going on here. Again, this is just like telling TypeScript, hey, trust me, it's going to be of this type. Now, if you don't want to do all that, you can kind of take it one step further, and you could just use a fetch that can kind of leverage. I have a code example on the next slide. So this is, I mean, there's tons of libraries like this, but this is just one example where you can say, all right, well, I've already generated my schema here. Now I'm just going to create a client that will kind of give me a little bit of a nicer developer experience where I can say, okay, if I forget a property there in my body, it's going to yell at me. Down at the bottom, if I, call a property that doesn't exist, it's going to yell at me. So again, what you really want to do is you want to have types. You don't want to write it all out yourself, because if you do, it's going to get out of sync with what the server has. So it would be nicer to generate it. So that's the goal. Of course, if you use GraphQL, you don't really have this problem, or you're already used to code gen, right? Like most GraphQL libraries give you really good type systems. Or if you're using TRPC, you're like laughing in the back of the room because you're like, we don't need any of this stuff like code gen. This is so 2021, right? Like TRPC is awesome, and you don't even have to do any code gen, right? Like it does some magic so that you can just call methods, right? You can expose methods on the server, and you just call them from the front end, and everything's type safe, and it's awesome. But it does require that you kind of control the back end and the front end. It does kind of have a bit of a proprietary thing going on that maybe isn't the best for like a public-facing API. And so, but if you can use it, great. Then you don't have to worry about everything we just talked about. So yeah, TRPC is really cool. It gives you end-to-end type safety. And if you can use this stuff, you absolutely should, right? Get the most out of TypeScript. Okay, so routing and navigation. I don't know that this necessarily falls like under IO boundary. It's sort of an IO boundary, but the idea is that in a typical routing situation, you're going to have routes with paths, and these paths are going to be strings, and they're going to have special placeholders in them that have meaning, and then you're going to render some React element, presumably whenever someone hits that route. So no issue here. This is good. But then, like, if I misspell something here, it's not even that it'll go to the wrong route. It's just like, I can easily put something in the to prop that just doesn't exist, because this component doesn't have any concept about what routes exist in my application, right? So, like a lot of mistakes happen in this space. And what's worse is you come over here to like the implementation of a component, and after you navigate to a component, it needs to know, well, what parameters were passed through. So it's going to say, okay, well, I'll just have a hook, use params. But like, what is the type there? Well, TypeScript doesn't know, right? And so what is the solution here? What typically, did the official docs tell you to do? Essentially, they tell you to do something like this, where it's like, hey, you just need to write the type at the top, which this type is not even right, but write the type at the top, and then just like throw it in some angle brackets. And again, this is just us telling TypeScript, hey, you can't infer what's going on, I'll tell you what's going on. But this is no different than a type assertion, right? I mean, this is the same as this, right? I mean, this is us essentially lying to the type system, and TypeScript will let that fly. Now, sadly, there's not much of a better option if there just isn't that many great options for like really type safe stuff in this situation. However, if you're daring and you want to use stuff that has a beta tag on it, there is type safe routing in the world, right? In fact, this is the only one I know of, and there's all kinds of magic going on to make it work because it is a hard problem. But the long and the short of it is, the community is really rallying around good type safety, and it doesn't come out of the box, right? You don't get really solid end-to-end type safety out of the box with TypeScript. So you have to do a bunch of stuff, but the community is making that easier. So I think that's really exciting. So what does the road to better type safety look like? Sure, you got to configure some stuff. Again, you kind of only do it once at the beginning of your project, but you got to configure some stuff. You got to avoid the bad parts. You want some better types for some built-ins. You got to do some schema validation. You're gonna have to write some Zod schemas or whatever library you use, IOTS, what have you. Type gen, it's a huge help. And then you just want to kind of lean on the ecosystem for things like TRPC and Zod. So that's my talk. I'm Simon. I'm a software engineer, founder. I've worked at a bunch of big tech companies. I teach TypeScript, among other things. And you can find, I don't have the slides up, but I'll put the slides up. But that's the link. You can find links to my slide decks. So appreciate it. Thanks, everyone, for listening to me talk about TypeScript. Thank you.
Great. Thank you, Simon. Community rescue, that's a new term I had not heard before, but I love the concept, sort of making our development lives easier as we go. And also, we have the community here today, so thank you for pointing out all of those helpful tools. And let's give a welcome to Enrique for the next talk.
Hey. Hello, hello. Testing. You listen? Hey. Nice. So, hello, everybody. It's a pleasure to be here. Okay. So, well, let me first present myself. My name is... I'm just waiting for the slides. Pretty much. Okay, so here it is. Nice. So, hello, everybody. First of all, my name is Enrique Inouye. Is this working? Okay, oh, sorry. Okay, so, back again. So, my name is Enrique Inouye. I'm a software developer at CodeMinder42, and today I'll be talking about Concurrent React, right? So, okay, so we start by drawing our attention to user interfaces. So, user interfaces, they are composed of many different parts. Some parts are very fast in terms of how quick they respond to user interactions, while others can be quite slow and may take a considerable amount of time to update. So if we take things like input fields, buttons, menus, sliders, these are examples of the fast parts. On the other hand, when we think of things like filtering a huge list, updating a dashboard, recalculating cells in a spreadsheet, or performing navigations, these are examples of the slow parts. So whenever you have both fast parts and slow parts in the same user interface, which is pretty much always, right? The problem is that the fast parts, they get coupled to the slow parts, in the sense that the slow parts, they drag down the responsivity of the fast parts. And to showcase this very concept, I just came up with a little demo here. So there's a bunch of steps you see here, so let me explain part by part. So at first, notice that we have some examples of the fast parts. So we have like a button, a text input, a slider. And at first, when we interact with these fast parts, notice that they respond to our interactions instantly. There's no delay at all. But also at the very bottom of this component list, we also have a slow component that's being represented by the turtle, the little turtle here, and also the checkered flag. And this component has been slowed down artificially. And whenever we click the Start Rendering button, it starts rendering. And it only stops rendering, it only finishes rendering when we click the Finish Rendering button. So right now, I won't go into details of how like this slow component works because it involves some like ancient magic. But if you're curious, you can come talk to me to break to find out. But going back to the demo, the one thing I wanted to notice is that once we start rendering this slow component, the entire user interface just freezes. Like notice that even though we have some fast parts like the button, the text input, the slider, when we're rendering the slow component, they cannot respond at all. The only thing that keeps on working, as you might have noticed, is the CSS animation, but it only keeps on working because it takes place on the GPU. But everything else gets completely frozen until the slow component finishes rendering. Now, the main takeaway here is that no matter how fast your whole user interface is, it only takes a single slow component to slow down your entire UI. Now, let's understand like why this is the case, right? So the reason why this happens is because the default approach React uses for rendering in most situations, which also for many UI frameworks is the only approach available, is to render things synchronously. So with synchronous rendering, once React starts rendering an update, it will run to completion, completely blocking the main thread. So in practice, this means that it doesn't matter how long the render takes to complete. Any user interactions that take place during this render will have to wait for it, regardless of how fast or urgent responding to them would be. So with that in mind, the problem is that like this is what causes the slow components to get coupled with the fast components. Because whenever you start rendering a slow component, you cannot respond to the fast components, right? But what if there was actually a way to decouple the fast parts from the slow parts? What if there was a way to let each part respond to user interaction at its own pace? So enter Concurrent React. Before we actually dive in how like Concurrent React works and how we can actually use it to make this decoupling happen, I just want to show you what it looks like from a user experience perspective when we actually use concurrent rendering, right? So first we have that same demo we saw before. It's pretty much the same demo. It has the same slow component, but notice that now, even though we're still rendering that very same slow component, the whole user interface does not freeze anymore. We can still keep interacting with it. Also, I'm going to show you two more examples. This first one is a navigation example. So it has a sidebar. It has like the page, and we're like transitioning to different pages in the application. And in the synchronous version, the sidebar gets blocked by this page transitions. And in the concurrent version, this just doesn't happen anymore, right? It works precisely as you would expect. We also have a list filtering example where we have like a normals list. And notice that in the synchronous version, the input field gets blocked by the list filtering. But when we use the concurrent rendering version, it just doesn't block it anymore. OK, so now let's understand a little bit of the bigger concept behind Concurrent React, because now you're probably wondering, how does this all work, right? And first, well, Concurrent React, it introduces two new features to rendering. The first one is interruptibility, and the second one is prioritization. So interruptibility is about being able to stop a render halfway through to do other things, and then coming back to it later. Prioritization is about rendering the most important things first. And when you combine both of them, React can start rendering something like the slow component we saw in the demo. And then if anything more important, more urgent happens, like, I don't know, like having to respond to the fast parts of the UI, we can like stop what we're doing, cater to these more urgent renders. And once we're done with those, we can go back to what we're doing before. And to do this, React allows us to mark renders as either high priority or low priority. And before we dive into what exactly these mean, I just want to make a quick disclaimer that actually we have more than 2 priority levels, but for most purposes in userland, collapsing them into 2 levels suffices. Now, high priority renders, they work pretty much like React pre-18. So like they are synchronous, they are blocking, they cannot be interrupted. But in this concurrent React setting, they are also able to interrupt low priority renders. Low priority renders, on the other hand, they are no blocking, they are synchronous, they can be interrupted, and they only start running after we finished all the high priority work. So just for us to actually understand what this means, I think it's useful to come up with a Git analogy. So let's say that we're working in an application, and you're using Git to track its code base, right? This is pretty common. I think everybody here does that. So we have the main branch, which represents the code that's in production. And whenever you want to write a new feature, you branch off main, you like do some work, and once you're done with that, you merge it back to main. So now let's say there's some critical issue in production, then you're gonna go with the hotfix workflow, right? So which is pretty much the same. You just branch off main, you do your work. Once it's done, you merge it back to main. Now, I wanted to consider what happens if you're working on some feature branch, but in the middle of your work, you suddenly notice that there's a critical issue in production, right? When that happens, definitely, like, if we think about it, solving this critical issue in production is definitely more urgent, more important than actually finishing this feature work for the time being. So supposing you're the only developer working on the project, what you have to do if that happens is that you have to interrupt your feature work, you have to work on the hotfix, and only after you're done with the hotfix is that you can go back to finish the feature work. So this is pretty much how Concurrent React works, you know? And if you've been paying attention, you can probably see how the analogy like maps out to the concept we just saw before. So we have the main branch, which equates to DOM, you actually see on the screen. We have feature branches, which are not as important as hotfixes, which equates to low priority renders. And we also have hotfixes which must be dealt with right away that correspond to high priority renders, right? So once we have these concepts in mind, the key to decouple the fast parts from the slow parts is pretty simple. We just need to assign high priority rendering for rendering the fast parts and a low priority for rendering the slow parts. Once we do that, whenever we start rendering a slow part, we can, and we need to respond to the fast parts, we can just interrupt that render, right? Now I want to talk a little bit about concurrent features because we saw all these concepts, but now we're going to see how we can apply them in practice, right? And to do that, we're going to go back to the examples we saw before. So first, the first thing we need to know about concurrent features is that when we do not use any concurrent features, all renders are considered to be high priority renders. So they are not interruptible, they are blocking. So in this case, this is the same example we saw before, the page navigation example. And notice that we're not using any concurrent features here. We're pretty much using a plain node use state, right? And because of that, all renders that are caused by updates to this state, they are considered to be high priority renders. So they are blocking, and this is why the sidebar gets frozen whenever we are navigating away to a different page. But now, when we start using concurrent features, and in this case, we're using, we basically have two new elements here. First, we have a new state that's going to track this, that's going to be used to inform these low priority renders. But we also have this use transition. So I cannot go into like how exactly use transition works, but the important bit is that whenever we update a state inside the start transitions callback, the render that is caused by this state update is considered to be a low priority render, which means it is interruptible. This is why, notice that now we're passing this delayed page to the main component. And because of that, even though like it takes quite a while for the page to navigate away, the sidebar can remain responsive. Now, let's go to yet another example, the list filtering one. So we have the same situation. At first, we're not using any concurrent features. This is why our text input gets blocked. And now in the second version, we're using deferred value. Now, use deferred value is, even though it has a different API from use transition, it works pretty much the same way. So whenever we pass a new value to like use deferred value, we're going to cause a re-render. But this re-render is going to be considered a low priority re-render. So notice that now we're still passing like filter to the input field, but now we're passing deferred filter to the filtered list. And this is what makes, this is what keeps the interface responsive, right? And now let's dive in a little bit deeper in how this whole rendering lifecycle works. So here we have the same example as before, but notice that on the right side, we actually have a console. And we're going to be showing, we're going to be logging to this console whenever we start rendering, we finish rendering, and whenever these renders get interrupted. So let's see step by step how this works. So at first, we type the first letter age, right, in the filter. And when we do that, because we're using set state to set the filter, this is causing a high priority update. So this high priority update render, the filter has, like, it's up to date, but the deferred filter is not. Notice that the deferred filter still has its, like, old value, the initial value, which is just an empty string. Now, as we said before, as we saw before, like low priority renders then only start after high priority renders have finished. So now that our high priority render has finished, we can start doing the low priority render. And in this low priority render, both filter and deferred filter are with the most up-to-date state. But the thing that happens is that before we can actually finish this low priority render, we type yet another letter, in this case, the letter O. And when we do that, because we're using set state, which is like which causes a high priority render, this low priority render is interrupted, and we go back to the high priority render, right? So it's basically the same thing. We finish the high priority render, and after that we can start the low priority render again. But this time we can actually finish the low priority render before we type another letter, and because of that, the UI gets updated accordingly. And we keep doing that, so on and so forth, until we finish the process. So I think this kind of showcases how this whole like high priority and low priority renders work in practice. And well, with all that in mind, I think it's just very important to like keep in mind that like probably you're all thinking, okay, so concurrent React is very nice. It allows us to make sure that renders not block right the main thread. So we should probably use concurrent features for everything. Well, actually, no, because the thing is, if you assign, like, if you use concurrent features for everything, you're just basically saying that everything has a low priority, right? And if everything has a low priority, it just basically means that there's no priority at all. So it would basically end up with the same problem we had before, because like without concurrent features, it just happens that all renders are considered to be high priority. This is why like everything blocks anything else. So our jobs as developers to work with concurrent feature properly is to be able to like identify which parts are fast, which parts are slow, and then we assign priorities accordingly, right? Also, one other thing I would like to talk about is just that it's important to keep in mind that concurrent React will not necessarily make your application faster. but you definitely make it feel faster, make it feel more responsive. And sometimes this is even more important than actually like making your application faster. Like, of course, if we could make your applications as fast as we wanted, like there would be no problems at all, right? But many times like there's only so much we can do in terms of how optimized we can make our applications. So if we cannot make our applications like lightning fast, the second best thing we can do as developers is to make sure we deliver a great user experience. And I think Concurrent React allows us to do that by making sure we can keep our applications responsive. So that is all I had for today. Also, like there's a post that I wrote that dives in much deeper in this topic. So if you're interested, feel free to check it out. It has like a bunch of demos and some of the demos we saw here as well. And well, that's all. Thank you all, and see you later at the break.
Great job. How many of you have ever tried concurrent rendering? Yeah? Anybody ever try multi-threaded rendering? No? Yeah, it's a really hard problem. There are languages out there that exist specifically to solve the problem of multi-threading and concurrency. So to bring that into JavaScript and React is fantastic. It's solving a lot of really challenging problems that hopefully by the time you all get there, you won't even have to worry about. Our next talk is about building a video game. How many of you out there are gamers? Me? How many game on PC, the best platform? All right, a bunch of friends of mine. So next up, the talk by Christoph will be about how to build a video game. This should be really exciting because it's one of those things that I take for granted all the time, but I promise he's going to enlighten us and teach us how difficult it really is. So give it up for Christoph.
It's actually not a talk about server components. No, you don't need to rewrite your app to use server components. Do it incrementally. Anyway, so throughout this talk, you might be thinking, what is he doing? Why is he doing this? And the answers are because I want to, because I can. So maybe just stick with me. The talk is actually not about how to build a video game. The talk is about how not to build a video game. And so to start off, I just want to jump in and show you a video of this game. So this game is called Athena Crisis. It's a 2D turn-based modern retro strategy game. It's similar to games that some of you might have played when they were younger. And the reason why I chose to build a 2D game with pixel art is because that's something that as a single indie developer with a bunch of artists, you can reasonably create. If you go into like 3D game development, it gets very hard, very expensive. And so in this game, you can control a bunch of units, you can move them around the field, and then you try to win, or sometimes you might lose. So I'm just curious, did anybody, sorry, there's no sound today, but did anybody notice something funny about this, or something weird? So this was actually a real game, and the AI was just playing against me. I can just jump in here and play against the AI. See a bunch of things moving around. I can use this, play with this unit. All right, and so one more thing is that this video game is not just running in my presentation. This video game is actually written in my, embedded in my presentation, which is written using MDX, which is a dialect of Markdown that allows you to embed React components. And it has hard module reloading. So I can just change it around, and then everything breaks. This keeps happening. I think what happens is when you switch the displays, things break. Same thing happened last time. Yeah, it's React. I also save while I'm typing to get the hard module reloading to work. OK, there we are. OK, so I think it's something about saving while I'm typing and hard module reloading. So it does work. And I can move around here, and I can swap it out again to the previous version. All right. And so once I realized I can put one game into my presentation, I also thought I can put 3 of them in there. It's kind of like, I've never been to New York, but people tell me this is kind of like playing speed chess in Central Park. And in this case, I just told the AI to play against me, and so that's what it's doing. Once it's done, I can jump into any of those games and play against the AI. All right, here, for example, I can just start moving around. I also realized I can just, because this game is available in various different languages, and it has internationalization, I can just change the language of this presentation as well. And then I realized, if I can embed the game, how about embedding the map editor that I built for this game? So for example, here, I can just pick whatever I want and just start drawing and like making a map. And what I learned by building a map editor, like what I wanted to do is that when a player builds their own maps or wants to share maps with somebody else, what I wanted to have is so that you can never create a map that is not playable or a map that doesn't look good, where some things don't fit together or where you have to spend a lot of time making them look good. And you only need two constraints for that. One is, can you place a tile on that field? Is it allowed based on what's around it? And based on what's around that tile, what should this one look like? And so you can start drawing. And the cool thing is you can do instant playtests. So you can just drop your units here in any color. And then you can just, with the press of a button, you can jump in and play. All right. So everything you've seen here is that something that was built from scratch with JavaScript, React, and CSS. And the stack is really amazing. It's using Beat, PNPM, TypeScript, React, Relay, Emotion, Prisma, GraphQL, GraphQL Pothos, Socket.io, and persistent data structures. So that's Athena Crisis. I used to work on testing a lot, so I also want to talk a little bit about the testing infrastructure. So when you're building a video game, you're making a lot of changes. There's a lot of complex state. There's mutations. There's all that kind of stuff that you're also doing in your forms and in your front-end code. And so I was like, how do I make sure that when I'm making changes, it doesn't regress, right? Obviously, you're going to go write tests. But there's a big difference between good tests and bad tests. And I thought, okay, maybe I can build a map renderer so that I have a map, and then I move a unit from here to there, and then it renders it to text, to ASCII art or something, and I put that into my tests. But then the problem is you end up having two different renderers for your system. You have two different, and they all lose signal, right? So you have all this, you saw all this art, right? And there's so much going on. And if you start rendering that as text, you have to keep maintaining that, and then that just takes a lot of work. So I thought, what about screenshot tests? Just capturing the state of the map at that time and then saving that as a screenshot test. And just as a quick example, this is the API that I came up with for writing tests. So for example, you have a map, you execute a bunch of actions against that map, you get a response back, and then you capture a screenshot of that state. I just want to show you how that works. So I have my tests running here in the terminal. This is actually live. This is my test suite running. Test might fail. If it's flaky, we'll see. And the cool thing is that in iTerm and in some other terminals, you can actually print out images. So while I'm developing, I can see what's going on in my game and if the state is correct or not. All right. Why would anybody build a video game with CSS, the DOM, and React? Right? I said earlier, because I wanted to and because I can. That's really everything that we need to say. But no, I mean, what you saw here is there's a bunch of reasons, right? One is instant load times, right? This game loads in less than 100 milliseconds. It runs everywhere. I can run it on my phone, on my desktop. It has smooth transitions, and you can get them pretty much for free with CSS. So for example, when I'm trying to build a unit, I can tap this circular menu. That entire menu is rendered using CSS and variables. The only thing that I'm doing with JavaScript, I'm telling it how many units there are going to be, and all the math, everything else, is in CSS to lay out the circular menu. And when you tap it, you can see how it kind of jumps out. It's just a really nice, smooth transition. Accessibility, browsers have really great support for accessibility APIs, so you can make a game like this also available to people that might have partial color blindness, something like that. Light and dark mode. So I can just change my computer to dark mode, and then the game and the presentation are both in dark mode. I don't think it makes any sense to make a presentation in light and dark mode, but I got all that for free. Downside is, and you might know that also, is that you might have to fight with performance sometimes. And earlier I was talking about persistent data structures to declaratively describe game state. I did a version of this in Japan, and we had the slides translated, and I just could not translate that one. So the cool thing is that I have this map, and anytime you execute an action against the map, you get a new state back. But because it's persistent data structures, I can have like 100 states of the map, and it uses very low amounts of memory. And also the cool thing is that I'm declaratively describing the game state. I'm just giving this game state to a React component, and I tell it, hey, go figure out what the game state, what that should look like to the player. And just to give you an example, here are like 30 maps. I just told the AI to play against each other, and then give me the game state and render each of the maps. And I put an FPS counter there so that you can believe me that it's 60 FPS. But 30 maps isn't cool. How about 3,140 maps? We can scroll for a little while. But the cool thing is I can also just jump in and play at any state of this game. I can just go in. I can also tell the AI to play against me. And then we can like go all the way down. Oh, I saw a few frames were dropping. Can go all the way down. Yeah, the game is almost over here. So the AI is playing quite a while. All right. So that's persistent data structures and a way to declaratively describe the game state. All right. So now let's play a little game. It's called Is That CSS? It's actually not a very fun game, because the answer to every question is yes. So when I tap one of the units, all of the ones that you can go to and like you can attack, they get this like red outline. And I'm not sure if you see this, but when you actually tap the unit, like it like comes out. You know, there's like actually a 200 millisecond transition there. I'm just going to prove to you that, you know, I got hot module reloading working here. Let me just get this in here. So these units, they have like a red drop shadow, and it's just a CSS variable. So let me just turn that into yellow. Wow, none of the demos work today. That's fantastic. I think the WebSocket connection is like breaking. Okay, right, there we are. All right, let's just see if it works. Okay, there we are. I think it didn't like rendering 3,000 maps. Okay, so I can just change that. When we like zoom in here a little bit, you can see these buildings, this building here. There's a unit behind it, and when there's a unit behind like one of these tall buildings, I try to fade out the building so that you can see that there's something going on behind. That's actually just a mask image with a linear gradient. And so if we get rid of that gradient, you'll see how that building is not transparent. It doesn't have this fade applied to it anymore. All right. Oops. When you like highlight one of these units, you see this arrow that tells you how this unit is going to move. And it has this marching ant. So I'm cheating a little bit because the arrows are actually using SVG. But then this marching ants animation, that's a CSS animation as well. And then do you see how this blue radius is like drawn? That's also just rectangles with a mask image and a linear gradient that's rotated and like turns off and on at certain steps. So yeah, it is CSS. If you're still not sure, I'll just go in here for a sec. Might be a bit hard to see in the DevTools right now, sorry. All right, yeah. We got all the units, everything here. That's, I think, the radius, and then the units are up here. There's a bunch of crazy CSS stuff going on, and I'll get to that in a second. All right. So one of the interesting things is that in games like this, you have something called fog of war. And fog means that you cannot, like, all your units have like a limited set of visibility, a limited range of visibility, and you cannot see anything that's outside of that range, and that's the fog. And so I went through a few iterations, but this is the simplest and most fun implementation that I've found. So this is how I'm rendering the fog. It's just a bunch of rectangles again. And then I apply a blur filter on it, and then I merge that layer into the layer below it to make it grayscale. It's pretty fun to play with this. And just to show you, when you move around, you reveal the fields around that unit. So for example, here, you reveal those fields. And when you turn off that filter, you have like hard edges. So that filter makes it look really good. For example, here, you see that this tree, the forest here is actually with using red trees. And you can kind of like see that shine through here. But if you make it look like this, it's just black. Let me just show you. Yes, those are red trees. All right. And just to explain it, so this is the really interesting thing here is that, in games like this, if you play them like locally, then all of the state is locally on your computer or your video game system, right? But when you're playing a game like this online, you don't want to have the whole state on each of the clients. You want to have a server that controls what is visible to each individual user. It's kind of like privacy rules when you're like maybe making a Facebook post and you're like, I only want my friends to see it, not my acquaintances, right? And here you have a privacy rule on each individual field on whether that's visible or not. So here are two maps, and they're both having the exact same state. And I'm the pink player in both situations, and in the one with fog, I cannot see everything that's going on the map. And so I'm just going to tell the AI to play around. And it's doing the same thing, but on one side, you can only see the things that are visible to that player. And so, for example, I can tap this pink unit and just verify if it has the same state here. Yeah, it looks exactly the same. So, obviously, if I'm a hacker, I can just go in, find that div with the mix blend mode and the filter that I showed you earlier and just remove that, and then I see everything that's below it. That's not how it works. That state is not available on the client. It's just on the server, and the server figures out what is visible to that player. And then there's one cool thing that, whenever you're using like a mobile device, especially iPhone, when you're typing something, and it will predict what is the next letter that you're likely to type. And then it will invisibly expand the area around that button. You cannot see that, but even if, for example, if it thinks that you're going to tap an E, but you like just get to the border of it and you tap a W, you'll probably still type out an E. And so the way it works is it actually increases the size of the touchable area of that field so that you'll always tap the right thing. So it's kind of like predictive typing, right? So in this case, what I thought about is that I want to make sure this game works really well on mobile. So it's kind of like, predictive playing, because I'm trying to figure out what is the player most likely going to interact with. So if it's your turn, most likely you're going to interact with your own units. So for example here, even though I'm on this forest, when I get really close to the next field, it will just grab the focus. So if I tap here, it will focus it. And then, once I focus that, it's like, what are you going to do with this unit? You're most likely going near another unit that's probably not yours. It's probably like from one of the other players. So even though here I'm on like the forest here, that helicopter unit will just grab the focus. So I can tap here, and it will still do the thing that I most likely want to do. And this is just a small optimization, but on mobile, it makes a huge difference in the user experience. Idle animations. Earlier, if you were looking closely when I showed you the dev tools, there was something like every 180 milliseconds, it was like flashing. And I found that CSS variables are just one of the most fun things and like one of the coolest inventions in like CSS. I grew up not having that, and like having that power is just really fascinating. So, we're all here in this room. We all breathe at a different cadence, right? And like a game like this, the breathing is a bit more pronounced. It's called an idle animation. It's not doing anything but breathing. And the thing with like CSS animations, that's the first iteration that I had here, was that when you add a CSS animation to an element, that's when that timer for that CSS animation starts. Or when you insert that element into the DOM for the first time. And so what happened is, you're building units at like a different time, and then they were all out of sync. They were all like going up and down out of sync, kind of like us, but, and that's more natural. But in a game like this, it doesn't look good at all. And so the solution I came up with is, so first off, on the bottom there, you see a sprite sheet. So there's like 48 tiny little images for each individual unit, right? And I just cycle through them every 180 milliseconds, depending on where it's which direction it's looking at, whether it's moving or whether it's just standing on the ground. And so the best solution that I found is that on the top level of my component tree, I have a hook that's called useTick. And every 180 milliseconds, it sets one CSS variable. And so each of the units just uses that CSS variable to offset which sprite to show. So there's no JavaScript running on each of the individual units. It's just at the top level. This is not very fast, but it's in sync. That's why we're getting to pitfalls and performance. So the game is actually rendered like this. And that is not very fun. If you have like a 30-inch screen, you'll probably not, even with some of the UX affordances about like, larger tappable areas, it's not very fun to play. So the first instinct is, oh, let's just use transform scale 3 to blow it up, right? But you can see that it looks a bit blurry, even on this screen. Sorry, it's maybe not as obvious, but it is like definitely very blurry. The problem is that by default, it looks a bit blurry. There's a CSS attribute called image rendering pixelated. That's exactly what I need for my use case. But the other thing is that there is a CSS property that was invented like 25 years ago, and it was only supported in Internet Explorer, and then Chrome and Safari and all of them had to copy it to be compatible. And for some reason, transform scale washes out all the colors, especially when you apply this like slight 3D transform that I have there. And with Zoom, you don't have that issue. Unfortunately, Chrome was about to remove this, but as far as I understand, I think Excel in Office 365 is using Zoom heavily, and apparently there's a couple 100 million users using that. So I'm really hoping that Zoom will stick around, or that we'll get an alternative that doesn't wash out the colors as much. And then I was very happy with 60 FPS in Chrome, and I went to Safari. I built my entire image rendering pipeline, image processing pipeline. I took all these sprites, and I just base64 encoded them into a single CSS file. And I'm like, this is amazing. There's one JS file, one CSS file. That's the entire client, right? And I learned that in Safari, for some reason, it wasn't running at 60 FPS. And you saw this earlier where I'm like, doing these idle animations every 180 milliseconds, and let's say there's like 50 units or 50 entities on the screen that are like changing what they look like every 180 milliseconds. And I learned that Chrome has a cache for like base64 encoded images inside of a CSS file, but Safari doesn't. So every 180 milliseconds, Safari would look at this base64 encoded string and be like, never seen that before, let's figure out what that looks like, decode the base64 string, turn that into an image, and then render it. And obviously that didn't work so well. So what I did is I deleted my image processing pipeline and just went back to regular PNGs, and that gave me like 10 to 15 FPS in Safari. And the point here is that if you have static images, base64 encoding them is probably a good idea. If you're manipulating what they look like on the screen by like, changing the background position of like an image, or like of an element that renders a background image, and if you do that quite often, it might not work as well. And then, in terms of performance, this is my daughter. This is Mia. She's 5 years old, and she comes to me. It's like, hey, Papa, I want to help you make your game. And so I said to her, okay, here's the map editor. What do you want to build? And she came, well, these tents are kind of cute. I want to put one on each field. And so she did that. And that shouldn't be an issue, right? There's like maybe a little bit of a campfire there that's like animated, but shouldn't be a big deal, right? Somehow, in Chrome, in every browser, frames per second went down to 7. It was not very fun to play. And so, did you see this earlier? I mean, I showed it, but like when you're playing the game, when you tap a unit, all of the things that you can attack get an outline. And I really wanted it to like come out in like 100 or 200 milliseconds, like, not just appear, but like have this like slight fade applied to it, because it just looks really good. Well, it turns out, even though on the internet people will say that transform and filter are GPU accelerated, they're good filters and bad filters. So in order to get this fade to be just right, you actually have to initialize some of the values. So the way I'm doing this outline is I'm actually using 4 drop shadows with 0 blur, 1 in each direction at 1 pixel. That gives you like a pixel perfect like drop shadow. But then the problem is I had to initialize it to be transparent so that once I turn it into red, I get this like nice animation. And so I put this drop shadow that doesn't do anything. It's not visible, right, because it's transparent on every single entity in the game. And browsers are like, oh, cool, there's a drop shadow. Then, I don't know how to optimize that, and everything got super slow. So what I learned there is that, there's some good filters and some bad filters. For example, using brightness, saturation, and grayscale is always very fast. Drop shadows can, you can fall off a performance cliff. And then, I had some other performance problems, and I saw this CSS prop. It's called will change, and it's amazing. It's like, hey, with will change, you can tell the browser, what you're about to do because like it will then figure out to do the right thing for you. And I thought, man, I'm so smart. I'm so much smarter than browsers. I know exactly what's going to change. And so I just put this like 2-line change into my code base. And then a few days later, I'm like, things have gotten kind of slower again. And then I realized, actually, don't use will change and maybe read the documentation, because I definitely didn't. So the interesting thing about this one is that it doesn't make things faster by optimizing it better because you tell it to optimize. What it does, it bypasses all the caching that a browser normally does, because browsers are really smart, and you can just tell the browser, actually, you don't need that cache. But most of the time, what I learned is I'm not much smarter than a browser. And browsers are very good at caching things. And so I stopped using it, and it's been much better for me. Maybe I should change the headline here to like read the documentation rather than not use it. There are some use cases. There's a red box there. Read the red boxes on MDN before you use something. The other thing that like is just really awesome is to always use an FPS meter. Every single page in the game, everything that you can see while you're developing, it always has an FPS meter on the bottom. You saw that in like some of the slides where I was like trying to prove to you that it's really fast. And it's just because when it's right there on the screen at all times and it drops, you know that you're having an issue. You don't just like go into the DevTools and it's like, oh, I measured my performance and I realized now it's slow. You have it right there every single moment while you're developing. And that's super useful. Another piece of advice is that, and I think we're talking a lot here about, server components, and people are like, okay, that's going to be so much faster, But quite often it doesn't really matter, right? Like it doesn't matter if you don't have any users, if your app is any faster, right? So what I learned is to benchmark early and often, but only optimize what matters. So in this game, I still have a bunch of things that are slow. It doesn't matter. And I have a bunch of things that were slow that I went on optimizing. So for example, I built this AI that you saw earlier, and I thought, man, I'm going to, I didn't know how to build an AI, but once I started building it, I thought, I'm going to build the most beautiful functional programming-based AI that I can ever imagine. I did like, reduce, map, filter, max spy, sort, everything, and it just, allocated a lot of memory, threw it away, and then mapped over it again and created some other objects just to like, build this beautiful AI. And then, it took like 2 seconds. And on the back end, that wasn't a problem. I didn't even notice. But then I wanted to run it locally, like in the map editor. And every time I ended my turn, it like does the entire thing for the next turn. And then, my browser locked up. And I'm like, OK, now I'm going to figure out how to put this AI into a web worker because it's so slow. And it's like, creating a bunch of complex infra to run the AI elsewhere. And then I realized, what if I just analyze my code and make it really fast, right? So I was actually able to just get rid of a bunch of that, functional programming of those patterns that tend to be really slow in JavaScript, make the AI about 30 times faster. Well, it took about 2,000 milliseconds, and now it's about 37 for like the same amount of work. And I didn't have to do any of that complicated work, right? Like I can also pause it, so I can just, use an idle frame, like figure out if the AI is doing anything or not. For example, while a unit is moving, I can have the AI figure out what the entire next turn should be. So now I don't have to build a bunch of complex infrastructure. And then in terms of tooling performance, I built this like library to do palette swapping. It's still not fast. I can improve it, but I just built it. And I built the entire thing while carrying a baby. And then it worked for me. It was great. But at some point, I thought, this thing is a bit slow. And so I looked into it, and I sped it up by 23 times. It's still not good, but it's a lot faster. What I learned there is just don't trust anyone carrying a baby and shipping open source. And yeah, I'm trying to open source as much as I can. It's not enough yet, but there's a bunch of things on my GitHub, a bunch of stuff on my blog that I wrote about, and there's more to come. And yeah, I recently started a video game company in Tokyo, and this game is going to be shipping in a few months, hopefully. So thank you so much.
Wow, thanks, Christoph. That talk had it all. Game within a game, what is CSS? Live demos, everything. So on that jam-packed note, it is time for lunch. We have from 1 to 3, a quick lunch break, and don't forget to check the custom map in the Slack channel. Also, as a reminder, from 2:40 to 3 o'clock, there is a lunch and learn in the sanctuary. It's called Improving Deploy Previews with the new Zeta workflow. Very interactive. As a group, anyone who attends is going to add a new feature to their Next.js application, adding things like likes to posts, submitting a PR, things like that. So if you're interested, go to the sanctuary at 2:40 and work with the Zeta workflow. And otherwise, we will see you back here at 3 o'clock. Enjoy your lunch.
Heart rush, head flush. It's like jumping into the lake at night. Is my love too much? 'Cause I feel like it's eating me alive. Do you feel the same? Caught up in the way we are made of the same pieces? somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now, 'cause I'm feeling worn out. It's getting to me, lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. Wanna be next to you, wanna be next to me. Holding our paper hearts, fading out broken dreams. Wanna be next to you, wanna be next to me. Holding our paper hearts, fading out broken dreams. Wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now, 'cause I'm feeling worn out. It's getting to me, lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. happened to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts. After all this time, there's nobody else like you. You captivate the night. It's all electric blue. After all this time, there's nobody else like you. Nobody, nobody else like, nobody, nobody else like, nobody, nobody else.
It's looking good. So, start to the wall. Hope for the best. Yeah, fuck it, we'll do it live. It got unplugged while I was moving around, yeah. Yeah, I mean, I like to blame you, so yeah, that sounds good. It was you, yeah, so like, yeah, how could you? You just don't care about me, is what it really is. I get it. I was just telling him earlier, I'm from Philly. Rejection and sadness is like a mainstay of my life. Should be 40, yeah. This is fine, yeah. Alright, cool, I'm good. Well, I'm not with. I'm doing the next call. Are you looking for somebody like that? Or Reactathon? I think that might be mistimed, but honestly, I don't know. So I'm not really sure. I would find Ben. Ben, he's the organizer. He was just in here. You can ask one of the elementary guys, maybe the guys there, but they're with Reactathon, but they don't do anything with the schedule yet. Yep, no problem. saw it now, but you're gonna be the only one there. Oh yeah. As much as you can. Interesting. Technical jargon. Yeah. Yeah, I work in it really depends on where you are, dude. It's like this is such a very niche, like specific type of event. So like we all are super nerds and care about all these things. Like most of the other web apps pay attention to it. It's interesting. It's an interesting career. Hello, hello. Let me get this mic fixed. Hey everybody, my name is Demetrius Clark. I'm the head of developer experience at Zeta, and today we're going to be going through improving your deploy workflows with the new Zeta workflow release. Quick little idea, we got 20 minutes, so I'm going to kind of zoom through a lot of this with you guys. I put together, it's in the Slack channel for anybody who wants to kind of go and do this on their own. Put together a little Notion workspace here. Step by step, you'll be able to follow through and kind of build this yourself. What are we going to be building today? So with Zeta's newest release, we've improved the branch workflow kind of to match your similar Git workflow that a lot of you have. You'll see a tiny GIF here that is in terrible quality that I put in there. It kind of explains that, as you're creating your new branches, trying to add new features, we've improved that workflow to allow the data that you're working with to never be tampered with and to bring that data to your deploy previews inside of your deploy previews. So we'll be doing that today. We'll be adding a new feature to our blog and an Next.js app. And I'm just going to jump right in because we have 20 minutes. All right, let's clear this out. So first, we're going to use dgit. We're going to grab the project from the repo that I set up for everybody. Reactathon Lunch and Learn. And we'll call it Zeta Blog. And we'll head over into Zeta Blog. We'll open it up. Cool. So we use dgit so that you guys can, again, as you're following along on your own, you can just get ready with your own GitHub repo, set it up, and deploy it to your favorite platform. We work with both Netlify and Versal. Today we're going to be showing you how to do it with Vercel, and deploying, showing you the full deploy preview process, and hopefully coming out the other end with some successful upvotes on our blog posts. So you'll see, pretty standard, Next.js 13 app. We're going to be using React Server components today. We've got a commented out post here. This will be pulling in data from Zeta that we'll be setting up. You've got a pretty basic page just showing you the home page. Let's just go ahead and init. Let's get our repo set up. Looks big enough. We're using the GitHub CLI, we'll be using the Zeta CLI and the Vercel CLI today. It'll just make it a little bit quicker for us to go through things. So GitHub repo create, and we'll add the source to be where we are currently, make it public, and push it. All right. As you can see here, we got a repo pushed up and ready to go. As you'll be doing this, again, your README is right here. You'll be able to kind of find the Notion doc right here as well. So now we can hop right into getting it deployed. So let's just deploy it. We will use our local my scope, set up a new project. So here we're just using the Versal CLI to deploy to Vercel really easily. Gonna wait a second for the Wi-Fi to let this build. In the meantime, 3 things you'll need for this: a Zeta account, a GitHub account, and either Netlify or Vercel, whichever one you would like to use yourself. Like I said, we'll be using Vercel today, so as we get this, oh, there we go, we're already ready. Here's our blog. Connect it really quick to our repo. All right. Still building. Awesome. Now that we've completed that, in your steps, you're going to see that we're going to need to auth with the Zeta CLI as well. I'm already obviously authenticated, so we won't be doing that. But in the steps, you'll see you'll auth with Zeta, you'll auth with Vercel, you'll auth with GitHub if you decide to use all of the CLIs. So at this moment, we can basically say, okay, great. We now are, I think we should have a production link. All right, cool. We're off to the races. So now we need to connect things with Zeta. So we'll use the Zeta CLI. And you'll see here we have a schema already set up. This will create your table for you, set up your columns for you. Really cool thing about Zeta, you can do this from the Zeta CLI. You can also do it right here inside of the UI, add a table, and get ready for this yourself. We're going to be using CLI, makes it a little bit easier. So we will upload the schema. select our database, select our main branch. Yeah, we do want to apply these migrations. And then you'll see we come back over to Zeta. We've got our post table set up, kind of some basic post stuff that you'd be using usually. And then we are going to now init. So we'll use Zeta init. This basically lets us say, okay, what database we're using. And then I think one of the cooler parts about Zeta, we generate your TypeScript client for you. Comes with your types out of the box, lets you import them around, makes it really easy to mess with your data. So we'll generate that TypeScript. We will put it inside of lib zeta.cogen.ts. And we will add it to our gitignore. Don't want to send the environment variables out to everybody. Great, so we've got our Zeta RC file. This basically lets us know, hey, this is the database URL that we're going to be using to connect to the table that we just created. And then this is where we're going to go, oh, not codegen, codegen. So we'll swap that as well. And so you'll see here, we basically just build a nice little TypeScript client for you, export it, and so now you can use this in any like Node.js-based environment to start putting together your queries. We're also built on top of Elasticsearch, so you can build search right into your UIs. Super useful, super helpful to be able to kind of just get started and running, and you'll see very soon when we start actually instantiating the client and using it because it's in TypeScript, we'll be able to easily start crafting queries together. So next, we are going to actually push this up with Zeta generated. Awesome. So now we can go and check, make sure that we are on the right track. And we are looking good to go. Great. We can move on to our third step here. And just give me 1 second. All right, so we're going to create our new branch. We're going to query the post from Zeta, and we're going to create the upvote button. So as of right now, everything has been a server component. At this point, we're going to be needing to add a new client component, which will be the upvote button. We're going to be adding upvotes. We're not going to be dealing with auth. We're not going to be dealing with a lot of error handling today. We don't have much time. So we're just going to show you how to build a really basic upvote button, hit a route handler, and get those upvotes started. So inside of that, we will create our, actually, we'll start up our new branch first. So we'll do git checkout, and we'll do add upvotes. And then this is kind of that same, similar idea of like branching workflow. We'll do Zeta branch add upvotes as well. Awesome, branch successfully created. We can go back to Zeta and make sure that that's true. We got our add upvotes right here. And we're actually, we messed up. So you can actually set it to, when you create the branch, to make sure that it grabs from the main branch. So we would do Zeta branch create add up, from main add upvotes. And this will make sure that when we have this new add upvotes branch, it'll have that same post database as well. So it'll pull over all of your main data. You'll see here that we actually don't have any copied data. So we'll have to generate another, we'll generate some data in here so we can use it locally. We'll generate some data inside of main. And basically this just generates like random hoo-ha. You see here, as long as it's text, but mail, Southwest identity, parse folk, it just generates random things based on the types that you've selected for the table. And we will now create our new upvote button. We'll hop into our post component, uncomment this, and as you'll see, we're pulling in here a post record. That's what you're going to be getting back when you start using posts. So we'll come back over to the main page, and we'll do a little bit of importing from our Zeta client. And I think we still got some time. So we'll instantiate it, get Zeta client, and it's as easy as this. We'll have posts equals zeta.db, and you'll see here we're getting our TypeScript autocomplete. We'll just get all the posts. So now we just have to render them. Thank you. We'll do post. And we'll send that post through as a prop. And we are missing a, there we go. What are we mad about? Missing key prop. Oh, wait. So we need to actually turn this into an async function. And await. We should get rid of all that yelling at us. What we got here? Missing key prop. Yep. Select a key. That'll be our post.id. And we'll import our post from app components post. We are going to spin this up real quick and make sure that we are looking good. All right, cool. So we got our post rendering. And this is all, again, this is currently coming out. So if you check into our .env, you'll see that we're looking at the main branch. And so as we, just created the new add upvote branch, we'll be switching to that so that make sure that when we are in development mode, we're looking at the new branch using that development data. And then you'll see when we actually spin up a deploy preview with a PR, the data will actually get copied from your main branch over to the new preview deploy so that you'll be able to actually work with the live data that you'd be working with in production anyway, but without actually having to touch the production data and mess with it in any way before going back to production. So we'll actually already swap this over to add upvotes. This is strictly for development mode, just to make sure that when you're in dev mode, you're looking at the right branch. And come back into upvote button. And we have a little bit of limited time, so I'm actually going to do a little copy paste in here, down here. And you'll see here we're using use client because we know we're going to be using some state and eventually hitting one of our route handlers. So we'll just set this up for now, render it inside of the post. Import that in. And now we have our upvote button. Upvote button does nothing currently. So what we want to do next is let's just spin up, let's do a push to our new branch. So now we've got posts rendering. And now what we're going to want to do is we're going to head over to Zeta. We're going to hit the settings. So you'll see here we have our workflow integrations. Again, GitHub, Vercel, and Netlify. We're going to be using GitHub. So we'll attach that. Whenever it wants to load. So we'll connect that repo. We'll head over to Vercel. Install our app. Hope that our continue button works. As we know, we're having a little bit of Wi-Fi trouble today, so thank you for bearing with me. Grab our Zeta blog. Great, now we're connected on both sides. We have both GitHub and Vercel. So now you'll be able to see as we're starting to create this PR. we've got a failure here in our Vercel. What is it made about? Looks like we're having some API key problems. Head back over and check. Check in Vercel and see where their M variables are saying. Looks like we do have the API key set. Gotta love live coding. Give me 1 second while I try and debug what the heck is going on here. How much time we got left? About 10 minutes. All right, well, let's just copy that over and see if we can recreate the environment variable for the API key. So as you'll see, usually when you're setting up these integrations, it actually, because of the integration with Vercel, it'll actually copy over all of your environment variables right in for you. Obviously, that's not working right now, which we'd love to see. Let's remove it. Let's add a new one. Okay. Let's do a redeploy and see if that works. Praying to the live coders that it allows me to work so I can speed through the rest of this demo for y'all. Look at that. Now it's happy. Thank you. Great. All right, cool. So now we can head back. Looks like we're good to go. And let's speed through as much as we can of this, try and get it done. Okay. So we have got our upvote set, and then we should be able to head over to Zeta. And then, okay, great. Oh, thank you, something's working. So the preview deploy has spun up, and you'll see if we actually head back over to the GitHub and check out our pull request. Right on the pull request, you have Zeta now giving you this link to be able to view this new production data in this preview deploy, and Vercel finally helping and working for me. So again, we can head over here, and you'll see the really great part is that we've got the same exact data set that we have in main over here in the preview deploy. So now we're working with the same data set. That makes me feel a lot more comfortable to be able to go and do something like this, where we're going to come and we are going to go to schema. We're going to say, okay, let's add a new column. We're actually going to do this on the add upvotes branch. So we're going to add a new column here. We're going to call that upvotes. It'll be an integer, and we'll make it not null and start it at a default of 0. And then from here, very similar flow to you're used to. We've made a change to the schema. So let's do a Zeta pool. We got to add the branch that we need. So add upvotes. And so we're making this pool, and in this pool, we're actually getting some migration changes. So now in your code, you're going to see what migrations were done as you're going through this process, and it'll stick in your repo with you, which is, I think, a really powerful piece of understanding, okay, what changes are being made, and what are they going to affect. That also does a regeneration for you of the code gen. And so now you'll see we have this upvotes. And again, this is all within this environment, right? So if I were to go back to the main branch, we won't see any of this. So now we've got upvotes, great. So now we can actually speed right ahead. Great. And so here was adding upvotes. And now one of the great things that because we have the upvotes, we can head right into our post. And for the upvote button, we're now going to want to send the upvote, or we'll do the post ID, which is going to be post.id. And we'll need that for making sure that we can do an increment on the upvotes. And then we'll also be sending through the upvotes. And so we'll have to come back into our upvote button, add these as props. We'll type it real quick. So our post ID will be a string. Our upvote will be a number. And now we can swap out that base 0 and just make the base state going to be an upvote. So the reason we're doing this is we're going to make it so that basically our state is our optimistic updater, so that when we are actually making these multiple clicks on top of the upvote button, we'll be able to kind of, as a user, see that these upvotes are happening. When you refresh a page, we'll do a whole nother call to the Zeta database, because we're going to be doing a fetch dynamic on the page where we're actually initially getting those posts from. So we'll do... Get out of here. Export const, and I believe it was up here. Force dynamic, and this again will let us, every time the page is refreshed, we're going to rebuild the page instead of it having to be just a static page. We can make sure that the data is right every time it comes through. Got about 2 minutes left. Let's try it. Why did this just change to that? What the heck are you doing? Go and grab the route handler code. So in here we'll create an API folder. Inside of that we'll create our upvote. And then we'll get our route handler started. Great. Come down here. This is what we're going to be adding inside of our try. So this is going to be doing our increment for us with Zeta. Super easy again, zeta.db.post.update. We'll do an increment right on the upvotes. Again, very basic error handling. We're just going to do success true, success false. We'll come back and we'll do a handle upvote function. This will be handling inside of the upvote button what we'll be doing when the upvote button is clicked. Sending the post ID in. So as you'll see here, we're getting the client updates, right? So we've got 5 votes, great. If we refresh it, we still got 5 upvotes. That's coming back from the server. So that was client updates, but now we're moving it back from the server. We're getting that re-render. And you'll be able to see here actually in the Zeta, we basically don't have any time left. Come back into here. And in our add upvotes branch, you'll see we're actually adding upvotes, coming back to the database, it's getting live. So from here, basically what you would want to do, I'll just do a quick wrap up of kind of the next steps. Next steps here would be just to push this up inside of the PR, then you'll be able to get those the deploy preview. When that deploy preview spins up, you'll be able to actually deal with the data that you're working with inside of your main branch right in deployment without having to go back to your main branch, without having to mess with any of the data. But it's still the same live data that you've been working with. I think this is a really important workflow, especially when like you've got so many people collaborating on a team. That's why Netlify and Vercel really excelled in the things they did when deploy previews came out, because it really pushed you in a direction of feeling much more confident when shipping new features, especially when you're working with a larger team. Even a smaller team, it feels very confident. So, like I said, my name is Demetrius Clark. Thank you for coming through with some of the stumbles today. Head on over to the Slack channel. Go through this yourself. It will not edit and problematically fail like it did earlier. Thank you so much, and have a great rest of your conference.
Great. Welcome back, everybody, for the afternoon. Did you have a good lunch? Yeah? Okay. I had pizza and a donut, so, that's fantastic on a rainy day. Anyways, back on topic. We are going to go into a fireside chat now. We saw some of the benefits and really cool things that CSS can do for us earlier today. And now we're going to hear a bit more about modern CSS and how it's just getting easier, faster, better for us to use. So please welcome Benjamin Dunphy and his guest, Nicole Sullivan.
Beautiful.
It's not bad. Can we have a round of applause for the venue and their staff? They've been just so incredible. They've been so fantastic to work with and so professional. Of course, we had some issues with the Wi-Fi, but that's because there's so many people here and we're having such a great time. And I'm so excited to welcome our next guest here, Nicole Sullivan. Nicole was lucky enough to be part of 3 major evolutions in the web. During the first, she introduced components to CSS and HTML, where she created the first design systems in 2006. And during the second, she was at Meta, probably Facebook, thereby known,
Yes.
when the precursor to React, known as XHP, was created in 2009. So many of you probably weren't born then, huh? And the next one is happening as we speak. And so after working as a web developer, Nicole joined Chrome at Google as a PM, where she could solve developers' challenges directly in the browser. She believes, if I may be so bold to read what you sent to me earlier, she believes developers have too many jobs to do, and she wants the browser to help. I love that mentality, so I'm especially delighted and absolutely honored to welcome you, Nicole.
Thank you.
So thanks for
Happy to
joining
be
me.
here.
And I wanted to start with the heart of the current thing.
Mm-hmm.
The current theme, which is on the tip of all of our tongues, which is React Server Components. And React Server Components is, in my view, a subset, at least in part, of performance, right? The goal here, one of the main goals, is to ship less JavaScript to the browser, to the client. And so, as someone who's been working with CSS for so long and is up to date on its latest and greatest features, what steps can we, as JavaScript developers, who may not be privy to all the latest and greatest tech in CSS, be taking to leverage modern CSS to ship less JavaScript to the client?
I think that's a really good question. I think we have these traditional lines drawn between what is the job of HTML, what is the job of CSS, and what is the job of JavaScript. And if you break it down, you can also say what is the job of the browser versus a JavaScript framework like React. And I think we've had these sort of rigid lines drawn between these various pieces, and we've said, no, that's only done in JavaScript or only done here. And I think it's important that we actually go back and question some of those and say, were the lines drawn in the right places? Are there pieces that maybe have been traditionally done in React that are stable enough that we should think about what would it look like to have part of that done in the browser instead? So when I joined Chrome, one of the first things I worked on was getting the Chrome team to be closer to JavaScript frameworks and to work much more closely with the core maintainers. So we had Sebastian and Dan and Brian and Andrew and other folks come and tell us what they needed out of the browser. And I think that made a pretty big difference to the perspective of folks working on Chrome in terms of thinking of frameworks as a partnership. And once you start doing that, you can ask yourself questions about, like, what should be done on each side of the line. And so, traditionally we've thought of JavaScript as being responsible for all of interactivity. I have kind of a spicy take that I'm not sure it should be. Like, JavaScript should absolutely be responsible for all the things that frameworks are amazing at doing. But I'm not sure like little random UI widget interactions, like accordions opening and closing, should depend on a bunch of JavaScript having shipped over the wire, and that it should wait for hydration to be functional. So the more that I can build an accordion or tabs or carousel or nav or tree view into the browser, then you can let JavaScript do what JavaScript is great at, which is very unique interactions, things that are like specific to your application or the problems that you're trying to solve, rather than having like, hey, you want interaction, you need JavaScript every single time.
So what are these latest APIs that we should be paying attention to?
It's funny.
Not to put you on the spot.
Well, I'm talking about one that everybody disagrees about. So I really love it, but not everybody loves it. So it may not turn out to be a thing at all, but it's a toggle API. And it's the basis of like a little mini state machine that would live in CSS and HTML. And the idea is that you could have some sort of user interaction on a trigger, and it could cause a state change on a target. And a surprising amount of the interactions on the web, menu opening and closing, pop-up, popping up, and then going away, they're actually they come down to that very simple principle. And so it may not ship at all because it's super disagreed about, to be honest. But I think it presses the right boundaries in terms of what can be done. So if you all want to try that API and tell me what you think, what you hate, what works and doesn't work, the idea of it would really be, if we can do things like baking accessibility into the browser, then maybe a developer doesn't have to think about their tab targets, doesn't have to think about their keyboard shortcuts for whatever ARIA role that they're using, doesn't have to think about the myriad problems that users have. Because you may have a user that maybe they want dark mode, maybe they're on a mobile phone, maybe they're on a tablet, maybe they use tap, maybe they have a braille reader, maybe they use a screen reader. I'm sure you feel this pressure where you have all these users and somehow you're supposed to meet all of their needs, and it can honestly feel like failing again and again. And so part of what I want to do is be like, hey, y'all, you have all these jobs and it's actually impossible for you to do them all well. So what if the browser could, for example, you use that API that changes state, what if we could update the accessibility tree ourselves? And in that way, you don't have to do it unless you're doing something funky or different than, it's just tabs or accordion. We all know how that's supposed to work. And I hear from folks who use assistive tech things like, people are doing a pretty good job of putting ARIA roles on things, but they never actually set up the keyboard shortcuts they're supposed to. So if you put like, ARIA for something being tabs or whatever, you're also supposed to implement what the arrow keys do and the enter key does and what the tab keys do. And I think that that's not reasonable for most developers. Like, even if we care a lot, and I think some care, some actually. I'm gonna be honest, when I do developer interviews a lot,
some care more about the developer experience than the customer experience.
Yeah, exactly. But I think even for those who care, they think they're not necessarily getting it right.
Right.
They'll be like, well, I tried for accessibility, but they don't.
So how do we get them to care more?
I don't want to. I want to say,
okay,
like, you should not, well, I might not say that spicy. I take it down one notch of spicy.
Sure.
I honestly think that it's too many things, because you also have the combination. You could have someone who's on a mobile phone in dark mode who uses a screen reader, and you're supposed to do all the combinations of those possibilities and figure them out. To me, it's not actually doable. And that's why I'd like for the browser to ship APIs that have accessibility baked in. Because if it does, then an average developer makes a button and it just works.
Interesting. So where are we in the state of the art of that?
Well, like I said, we have the toggle, extremely disputed toggle API.
Sure.
And then we also are working on what it would look like to take summary details and turn it into an accordion. We're looking at adding a select menu, which can be stylable and you can have custom content in it. We're looking at other components. Right now we're designing a carousel Not your like big hero carousel thingy, but like a product image carousel.
But in terms of the
kind thing.
roadmap, how far along are they? When can we expect them? Or are these still up for debate?
You know, it's standards. Everything is up for debate forever, if we're being honest. Some of the APIs are available now. What we started with in terms of our roadmap was, hey, there's just missing stuff from CSS. Like, we see people doing things like using CSS and JS, where all their CSS is parsed once as JavaScript, parsed again as CSS, and only then can be rendered to the browser. We're like, okay, there's clearly missing pieces here around like scope and nesting and other stuff that like architecturally CSS just needed so that everything isn't in the global scope. So we had a sort of list of 7 or so APIs that were in our top set of developer requests for architecture. By the end of the year, we should have shipped 6.
Okay. All right.
Yeah, so that's good.
All right, let's all hold it to that, okay?
Do hold me to it. For
At
sure.
Stubbornella on Twitter.
And then for the components,
Yep.
select menu, we have a target by end of year. It's looking good. The things it relies on, which are anchor positioning and popover, are coming along really well. Popover is being able to put something in the browser's front layer. So instead of having to use Z-index or whatever, you can actually pop something into the front layer that the browser itself would use. And anchor positioning means that without any JavaScript, just CSS, you can anchor something around another element. And you can say, hey, if there's enough room, it should be top right. But if there isn't, then pop it down here and give your sort of stack of preferences about where something anchors. Which you think that's not that much JavaScript, but most teams that I talk to are like, yeah, but it's really painful to maintain that JavaScript. So that, you know, our goal is to ship select menu, but we also ship all the low-level APIs you need to make select menu that then can be used for hints and tooltips and other things.
Now, fast forward to the point where all of these APIs that you just mentioned are live. They all live in the browser. You can access them today across all.
All
Okay,
browsers?
All browsers, like,
Okay.
you know, the asterisk, of
I
course.
like this
with all the
feature.
others. This is a great feature to think about. Make the case for someone who is hesitant to spend the time to refactor, to integrate these. What performance gains? I mean, this is obviously going to vary wildly across the many different applications that are out there. But just make the case for them. If you're speaking to someone who's got, let's say, we're at a React conference, who's got an Next.js app, who's, you know, maybe it's a B2B app or maybe it's a B2C app, whatever it is. But make the case for why they should care about these, at least look into them, if not actually adopt them. Or more urgent if you feel.
Ooh, which reasons do I want to pick? I think I'm going to talk about 2 different things.
Sure.
The first one is developer productivity, and then we'll see if I have time to get to the next one.
Yeah.
So when I started this effort, I went and I tried out 50 or so different commerce sites because I thought this is a great way to sort of see like the standard shopping flows. How are we doing on the web? And so I went through shopping, product details, product list, product search results, and then checkout flow, including the cart. And I did this for 50 sites. And honestly, I would have kept better data, but I was looking for a good one, and I did not find a good one.
Oh, interesting.
Every single one had bugs. If you like swiped the product image carousel too fast, the wrong indicator would be lit. Sometimes the scroll didn't work. It wasn't matching browser physics. So like you're swiping the carousel and it's like jagging its way along or it's way too fast. So there were also, and oh my God.
The scroll hijacking is my pet. I hate it.
Yeah.
I will close your site in half a millisecond if you're hijacking the
I have one that's
scroll.
worse though.
Yeah, what's that?
Product image zoom, where half the time you zoom in on the product image and it's actually smaller than it was before.
Oh my God.
Or it
What?
opens bigger and
I think I've seen that.
The X is actually covered so you can't figure out how to close the
Yep.
opened product image zoom.
Or escape doesn't work.
So I found one site that did well and I didn't find
Out
a
of 50.
single bug, and it is a React app. Yes, out of 50. And they were 50 chosen randomly and not necessarily like representative.
Yeah.
This site, it's called babylist.com, and it...
That's the good one?
Yes.
I'm actually using
I mean,
that.
at least it was a couple years ago.
I
Yes.
like that site.
It's
I'm
a
using
good-
it right now.
Yeah,
shout
it's
out,
a really
shout out
good
to Babylist.
site.
Yeah.
Shout out to Babylist. Anyway, I asked their CEO, like, how did you achieve this? Because that's pretty incredible. And she said it took 6 to 8 developer weeks for their product image zoom and their carousel. And she said, and they have ongoing maintenance when there are bugs or browser updates and that sort of thing. And so I thought, well, okay, could we set a goal that a developer wanting to ship a product image carousel only needed 1 week or less? And so that's our goal.
So you reached out to them.
Yeah.
It's like, hey, we're gonna help you
I'm
make
like,
this
how
even
did
better."
you do this?
Yeah.
Because you're the only ones. And I looked at big retailers. I wasn't, you know, I was looking at
Sure.
sites where you'd think they
Yeah.
would get it
so,
right.
So they have the resources to engage you, to connect, and to implement these. So back to the original question, what's the case you make? Like, were you making the case to them? So that's where you're going.
Well, I mean, I'm making the case to y'all because we're in a future, right? Your question was we're in
The
a,
hypothetical
the
future,
hypothetical future where all of
which
this
is
is available.
absolutely going to happen.
Like, you spend a lot of developer time, I'd imagine, on things that are not the most fun and are sort of repetitive. Like, how many folks here have built a tab set? Okay, almost everybody. How many people have built it more than once? Yeah, okay, so that's what I want to solve. Because the other thing is I talked to another, this time a big retailer, and they had 7 different tab sets in their like design system. And I will say there are a shocking number of design systems at companies as well. So, you know, one company may start with a single design system and then it sprouts other design systems. And so if you can take the effort out of making the base components like tabs or accordion or carousel, then the work to do to like brand those is a lot smaller.
Very nice.
I hope so.
So no percentage performance improvements, et cetera. Like, is that too difficult to like fathom or postulate, or?
There is, I think there could be performance improvements.
Yeah.
It's hard to measure ahead of time until we have working code, but where I'm focused is on INP, interaction to next paint, which is the user does something and clicks or something like that, and we count the time until the browser can paint the next frame. I'm particularly excited about this because a lot of the early Core Web Vitals, they focused a lot on the multi-page app experience, which is important to a single-page app too, because that's your user's first impression, but they didn't necessarily capture those subsequent user interactions. And so I really like INP for the way that it, you know, a user could be several views deep in a single-page app built with React, and they'll have that, you know, those measurements taken as well.
Yeah, and I want to get your unfiltered opinion on React. I mean, because it's an interesting case study because you founded what then became Project Aurora. So for those who aren't aware, Project Aurora is a small team at Google, and Google Chrome more specifically, that works directly with libraries and frameworks such as Next.js and the React team, and I believe also the Vue team.
Nuxt and Gatsby.
And Nuxt and Gatsby.
And they contribute, anytime they can contribute to a lower level, they will. So, you know, if they can contribute it to like an infra tool, and that will get out to all the frameworks, they do that. Yeah.
And when I was talking with Hussein Jurde from the Chrome team about this, he
he's
said
great.
that the goal of the Aurora team is to make the web better, and this is why they're working together. So what inspired this work, and how has it been? I know you're not currently with the Aurora team, but how has it been working directly with those teams, and what has transpired from that? And what can you tell the audience here, both in person and live, about what has been accomplished from that relationship?
I don't think it's hard to even put into words how much it changed things. When I joined Chrome, there was sort of a sense of an adversarial relationship with frameworks. I don't know if folks remember that, but there was just this, I just didn't understand why. It seemed really silly to me, like we should be on the same team. Clearly we have the same goals.
It's on the web, yeah.
But it was this adversarial relationship, and I think now a huge part of our strategy as an entire organization is that we're focused on how do we meet the needs of abstractions and tools, and frameworks fall into that bucket. We did a little study where we looked at like who were the developers that were using vanilla JavaScript, and what we found is they were most likely to work on their own, just themselves or maybe one other person. They were most likely to not use any other tools, to not use NPM, to not use like the standard set of tools we've all gotten used to. And so the conclusion I drew from that was these are hobbyists, or maybe students, but probably hobbyists. And so that allowed us to switch things around and say, no, the bulk of the web uses frameworks, cares about frameworks, want their frameworks to be good and fast and everything else. So that really switched us to thinking about how do we make framework authors happy and framework developers have great outcomes. Yeah.
Wonderful.
And then the React team, I should just say, was
Sure.
amazing. Like, they worked with us when we still had no idea what we were doing. They spent a ton of time with us being like, nope, that's not how hydration works.
Yeah.
So that we could learn and start to, both put stuff in the browser that was useful, but also contribute performance-wise to these
Absolutely.
tools.
I won't linger on this because you're not doing this presently. And if you're curious about that, I did interview Hussein Jurde, so that is on the Real World React YouTube channel. So presently,
Yes.
what are you doing day to day at Chrome?
Yeah, I'm the product manager for Web UI. And so that includes everything from like style and CSS, layout, to some degree paint. It's DOM and HTML. It's UI dev tools, so everything that's in the HTML and CSS panes and dev tools, as well as like animations and some other ones. And then it's also our interactions team, so they focus on scrolling, interactions, taps and touches, and on animations. Although some of that last bit, I found a new PM who's going to take some of it on, which I'm really excited about.
Oh, wonderful.
Yeah.
Wonderful.
And so basically, I look at what are the problems you all are trying to solve, like interactivity, dark mode, accessibility, what features are you trying to ship, and I figure out what are the missing pieces in the browser that could make your life easier. Someone asked recently for, could there be a declarative date time sort of element thing? So my job is, right? Yeah. Yes, and arrange for dates and people, I mean, these are just requests. I don't know if we can do them, right? We got asked for them last week. So, but yeah, we get asked for these things. And then similarly, like formatting numbers, like should you use decimal points or commas? It depends on where you are in the world. Like, so could the browser solve some of that? And so those are the sorts of problems where my job is to go and talk to you all and hear what's broken, what isn't working, or even just like what problem are you done solving and want someone else to solve for you? And then I go and figure out in the browser teams, like, does this make sense? Has anyone tried to do it? How hard would it be to standardize it? And put a proposal together, and then we work it through the standards process. And I would say a lot more ideas go in at each stage. It drops off, but it's great to have that sort of flow through of ideas from the developer community to the.
And very quickly, for those who are not aware, can you just talk us about the standards process in like 30 seconds or less?
Yes, I can try. Wow. So there are a lot of different working groups. They all have overlaps and differences. So we have the working group for HTML. We have the CSS working group. We have various working groups that help out with accessibility-related questions. There's a whole process, and there are articles, I think, on web.dev you can look at if you'd like to understand it better. But essentially a process of going from an idea through to something that can actually ship in multiple browsers. And we have like intent to prototypes and intent to ships, which are essentially like us sending up a signal and being like, please give us feedback. We made something up. Does this make sense? Yeah. So.
Got it. Thank you.
Is that 30 seconds?
I don't know.
Okay.
And sorry for making it. I just didn't want to go on a tangent on
Fair.
that specific topic. But where is this in the standard cycle? Chrome shipping React in the browser.
That's like the third time I've gotten asked that at this conference. Yeah, a lot of people want to know, like, why not just ship React in the browser? Yep. I asked that question of my engineers also, just to see what they would say. My take on it now is this. Each layer of the web platform operates at different timescales and can make different kinds of changes without breaking the whole web. So we think of React, right, as having to be like incredibly stable and not break all of your sites. But if we look at the layer lower than that of Chrome and the browser, we have to be even more stable. And y'all do really weird stuff sometimes. So we have to make sure, like, people will add a property in CSS that doesn't do anything now, right? But then if we want to add that property later, we have to look how many people did that when it was a nothing, when nothing happened as a result of it, so we don't break all of those sites when we do. But the point I'm getting at is the web platform can't move very fast, both because of standards, but also because we just can't be breaking you. And so I think that there's stuff that React does that makes sense to move into the browser wherever it makes sense to framework authors, where they need something from us. But we have to be really thoughtful about what's stable enough to migrate over the line, because once it's in the browser, it's incredibly hard to change. So I think there's like innovation at every stage. You innovate in your own app. It's on a meta framework and framework like Next and React that innovates or Remix. And then you have some amount of innovation at the browser level, but it's more, it's slower.
Okay, so if you had to guess at a timeline of when React would be in the browser.
Tomorrow.
All
Didn't I tell
right.
you that's in our release?
A big announcement coming from the Chrome team. You heard it here first.
I think that parts of it already are. Like, the reality is, like, we got feedback that changed the course of our roadmap from the React team starting, I don't know, that was around when I started at Chrome. So I'm going to say that was like 2019 we started working with them and honestly meeting with them every single week to figure out what the direction of the browser should be and how we could help with the framework as well. And so stuff from that has already shipped in Chrome.
Got it, interesting. Let's switch gears a little bit. We got a few minutes left. Utility classes. They've always been a thing. But there's a current level of excitement and also debate, particularly with Tailwind. So what do you make of this new resurgence and this excitement, particularly in Tailwind?
I kind of came up with utility classes, so I think they're great. But, welcome.
I should have known that.
Well, yeah, most people don't. I can show the GitHub receipts.
Put it on the
I swear.
LinkedIn.
Yeah. Put it on LinkedIn, yeah. So it looked like, spacing classes that could give small, medium, and large spacing. It looked like stuff that did, topography and colors and all the stuff that changes from view to view, and so it's very hard to say exactly what it should be. I will say I think Tailwind has taken it too far, in that I think that I don't know. That's basically me saying I think I'm right, so bear with me. But the way that I thought of it was this: every component should have its default behavior, its default spacing, its default colors, which all work, because a whole lot of people are going to use your components who have no idea what color anything should be or how much space should be between anything, and given any rope, they will make mistakes. And so not having those sort of opinionated components feels like a missing piece to me. I saw the utility classes as modifiers for that. So you have your base component. Now you need it to have more spacing because it's a marketing page. Great, add a utility class for more spacing. But I think a lot of stuff lives, a lot of meaning lives at the component level, and I don't want to lose that, basically. Okay. So I think both sides are right, and if they stop fighting, it actually works really nicely together.
Interesting. Let's end on a light note. Why are there so many ways to define colors? What can you tell me about this new OKLCH thing?
That's so funny because I said the same thing to the folks that were designing the new colors. I was like, did you really need that many of them? What's going on? And then they showed me some of the stuff that you could do with them that you couldn't do before. And the old colors, really, they all went through these murky gray, brown colors in the middle if you did gradients. So you'd start at one color and end at another, but somehow it would go through a murky, gross color in the middle. And the new color spaces are beautiful, right? So they might go through a bright, beautiful color in the center that's actually creates a gradient that feels nice. I think similarly, some of the color spaces add a vibrancy. When I first look at some of the images that were done in the new color spaces, it actually hurt my eyes. They were so bright.
Oh, wow.
And I was like, okay, there's something to this. So yeah, it's a lot of color spaces. I still agree with that, but I think that they provide different things. And my hope is that they allow us to do things like create whole color systems where you're not having to individually pick a whole pile of colors. Instead, you pick one or two, and you're able to set up a system where those those colors filter out into your into your whole application, and include things like appropriate color contrast and that kind of thing.
All right, Nicole, I really appreciate you joining us. It's been
Thanks
such a
for
lovely
having me.
conversation. Great to meet you. Can we give it up for Nicole, everyone?
Thank you. There you go.
Wow. Well, thank you so much for that conversation. I don't know how many of you have done this, but that really resonated with me. I have built an accordion multiple times, rebuilt a button dozens, if not hundreds of times, depending on what company I'm working at. So, that's unfortunately the way of the web today. So I'm excited to see what comes out of Nicole's work and her team. So let's give them a round of applause. Amazing. So we're going to switch gears a little bit. We're going to, go from the browser to our friends, the robots. So we're going to hear some about AI for the rest of the day. So please welcome David.
All right. Hello, everyone. I wouldn't call them technical difficulties. They're more like physical difficulties. But anyway. Hey, my name is David Khorshid. I'm at David K. Piana pretty much everywhere, and I'm so excited to be back at Reactathon this year talking about something completely different, making state management intelligent. Like, what exactly does that mean? Anyway, I have less than half an hour, and I have a ton of information to give to you, so let's just jump right into it. First of all, I work at a company called stately.ai, which is really apt because I'm going to be talking to you about two things. First thing is states, and the second thing is AI, of course. And so I'm going to have two very important takes, and I don't know if they're hot takes or not, but we'll see. We're going to have two takes at the end of this talk, and so just try to keep that in mind. But first, let's talk about states. I think that as developers, especially React developers, we have a plethora of options on how we manage states in applications. And so we could, have all of these different hooks and state management libraries. And sometimes we think, okay, there's trade-offs, like we're going to use one over the other because I like the simplicity versus I need to manage complex state. But in reality, I see it more of an evolutionary path, where as our app gets a lot more complex, we have more code, more features, we have to eventually graduate from simple things like use states. And we might start using useReducer because we want to organize our logic a little bit more. And so, applications do get a lot more complex. And so that's why it's good to just know all of the different options that we have. By the way, don't look too much at this code. It was generated by ChatGPT, so I cannot attest to the quality of it. There's also use effects when you actually have to start caring about effects. I gave a whole talk about that last year, so I'm not going to get into it this time. There's use context when you're really nostalgic for Redux and you want to build it yourself, and you also don't know when things are going to render, and you're totally fine with that. So there's use context for shared state, stuff like that. There's use sync external store, which is really useful for just having, external stores. And I wish that this was a friendlier name, because really this is like a library author hook, but it's honestly one of my favorite hooks for managing state. And then we have a plethora of options for just different state management libraries. And so the reason that I'm showing you all this is because our applications have different needs, different use cases, and as developers, we use a variety of these solutions to get an application to get what the user wants to do. And so this has been working pretty well for many years. There's people successfully using whichever state management library, and I'm not going to convince you to use one or the other, or whether you should use a state management library or something like that. That's not really my point. My point is that right now, times are changing. And so, you may be familiar with one of the biggest advancements that happened in just in technological history, at least in my opinion. And not to overhype it, but of course we have ChatGPT, GPT-3, 3.5, 4, and now they have Company. So this is all based on what's called an LLM, or a large language model. And so you have many I don't know if we want to call them competitors, but like many of these other LLMs have entered the arena, so to speak. So we have Claude from Anthropic. We have a variety of open source software solutions like Facebook's Llama. And even just yesterday or 2 days ago, they announced OpenLlama, where they're actually recreating Llama from scratch so that it is actually like more viable for commercial usage, et cetera. Sydney from Bing, Bard from Google, and now we're even having on-device LLMs. So this space is getting really crowded, and of course it's super, super hyped right now. And the reason is because users, they want to take advantage of AI, and now our expectations for how we build applications and what we provide to users is changing. Users actually want intelligent apps, more or less. There are some people who say, I don't really want to have AI do things for me, and for good reason. I completely understand that. But, you know, just if you're working with Notion or things like that, it is really useful to have AI just basically do things for you. And how many of you are using Copilot or ChatGPT or any of that, like just in your daily work? And that's pretty much most of you. So, you know, it just goes to show that you do want, and users do want intelligent, whether you're a developer or a user of an application. But it's sort of strange right now because the nature of LLMs and using generative AI is that we're basically making API calls that are slow, they're expensive, you know, of course, sometimes wrong, and, you know, this is, they're impossible to debug, and so this is suboptimal and bad coding practice, but all of a sudden we slap an LLM on it, and now our company is worth $100 million because investors decide to throw money at it. However, despite all of this, I would say that LLMs are not enough. And so these are 3 recent articles that came out within the last week where, you know, one is saying chatbots are not the future, which I agree with. There's also the UI's ChatGPT won't replace, where it argues that user interfaces are still really useful. Again, we're not going to try to transform everything to a chatbot. And also, unpredictable black boxes are terrible interfaces, just because we cannot predict, like we don't have a predictive model of how applications are going to work, right? So if a user does something and we don't get the expected output, now we're like, okay, what's supposed to happen here? Do I have to tweak the prompts? Do I have to like say the right magical words to make it work? It doesn't become that good of a user experience. And so in my opinion, I think the core of this problem is that LLMs operate at this level where you have an input and it does its magic in its black box, and then it produces an output. Whether that output is acceptable or not is up to the user, but what we really want is to be able to express a goal and to have the AI or the application, whether it's using AI or not, actually achieve that goal somehow. And so, funny enough, there are actually LLM-based technologies doing this right now, such as Agents GPT, LangChain, AutoGPT, and actually Agent GPT uses LangChain. The idea is that these are using what's called chain of thought reasoning. So the LLM is able to ask itself questions, and it gets in this loop, and it's able to accomplish those set of tasks and reach that goal, hopefully, and eventually. And there's another one here where I'm including it in its own slide just because there's a state machine, which was created by Sean, so I like it a lot. But it actually really clearly shows like what's actually going on, where it's basically asking itself questions, it's storing its context in a vector database, and then it's just going until all of its tasks are completed. But I actually want to take a step back, like way back to 1980s, when the idea of what's known as reinforcement learning was first introduced. And so if you take anything from this talk, well, I actually really want you to take 2 things, but one of the things is, just what reinforcement learning is, just because I feel it's really important to learn what it is. So in short, reinforcement learning is an intelligent agent learning through trial and error how to take actions inside of some environments, whether it's known or unknown, in order to maximize a future reward. And so there's a lot of really cool things in research that has actually come out of this. One of these is more recent. I think this is from 2021. Google Research did a thing where they basically took the standard models of just agents being able to play Atari games, and they gave it a discrete world model, so it was able to actually understand what was happening in the world just more intelligently than doing random actions and things like that. And we're going to be talking about that a little bit later. And there was also this more recently where you have these little bots that learned how to play soccer. This is just one of the videos. I really encourage you to check out all the other videos. Also, have we not learned our lesson from pushing over robots? Like, this is going to backfire, seriously. I mean, Boston Dynamics, right? But at least this one is cuter than that evil robot dog. So it's still pretty cool. All right, so how does reinforcement learning work? Well, I made a state machine for it, of course, because that's who I am as a person. So we start by an agent observing an environment. And so in observing the environment, it's selecting an appropriate action based on its policy that it's learned. And so the agent chooses the action, and the environment reacts in some sort of way. So, for example, actually I can't really think of an example, but I have examples. So when the environment reacts, something can happen. Either something good could happen, like a reward, and based on that, the agent will actually say, hey, that was good. I'm going to remember that that was good, and I'm going to update my policy based on that. Or something bad could happen, or you might get no reward, and it just continues the cycle. So if you think about it, this applies to games, this applies to robotics, this applies to a lot of things where agents are basically going through the cycle, choosing actions, and at every step determining, was that action good or bad? If it was good, I'll probably repeat it in the future. And if it was bad, I'm probably going to avoid it in the future. And this is how agents can actually learn to perform tasks and reach an eventual goal. So one of my favorite examples of this is actually Pac-Man. So Pac-Man can be considered the agent. The environment changes. So you have, for example, normal mode where Pac-Man is just vibing, eating pellets or whatever they are. There's cherries in there too. And there's also ghosts chasing him. And there's also scatter mode. So when Pac-Man eats the special pellet, I forget what it's called, then the ghosts become edible. And Pac-Man's able to chase them. And so the behavior of the environment actually changes. And so Pac-Man is able to do something different. So Pac-Man in this case is the agent. And again, at every time step, Pac-Man is going to do one of two things. First, it's going to observe the state of the environment. What's going on? Is a ghost about to chase me? Or am I just in front of pellets that I could eat? What should I do? And then based on the state of the environment, the agent will take an action. Move up, move down, move left, move right. In other video games, it's much more advanced. In robotics, there's many other things that it could do. Now, the agents could actually do many things. And so this is part of the policy which we'll talk about. So for example, the agent can eat pellets. The agent can run away from ghosts. Or if the ghosts are edible, the agent might decide, you know what? I'm actually going to eat those ghosts just because I know that that's a good thing to do. Now, how does the agent know whether something is good to do or not? That comes down to the policy. The policy informs the agent, if you're in some state, here's all of the possible actions you have. And based on either some stochastic policy or what has happened before or just some deep learning or something like that, it's able to say, I'm going to choose this action because I feel like I might get a reward if I choose this action. And so the policy informs that. This is actually from a site that I saw where there's actually, did you know that there are strategies for Pac-Man? I'm learning for all of these old video games, there's actually really, really interesting strategies. So if you go in the red areas, I think either those are areas to avoid because you're going to get eaten by a ghost, or maybe those are strategic areas. I forget, but it gets really, really interesting. And there's also rewards. So rewards happen based on the environment. So, you could get eaten by a ghost. That's a bad thing. Or you could, just survive. And even surviving could be a reward. And so that's why the policy is based on something known as credit assignments. And so this is how we shape what the agent should be doing. For example, we could tell the agent that, you know what, eating pellets is good. You should keep doing that. Or you could say, you're getting chased by a ghost. If the ghost eats you, that's actually a really bad thing. And so that's why things like score are a great proxy for things like, you know, did I do good or did I do bad? So why am I talking about all this in, you know, in the context of what we have right now, which is ChatGPT and, you know, large language models? Well, the truth is that ChatGPT operates on something called RLHF, or reinforcement learning with human feedback. Sorry. And so this is in contrast from something called supervised learning, where basically with supervised learning, we're saying, if I give you a prompt, this is an example answer, here's another prompt, here's an example answer. And obviously that doesn't work with something like ChatGPT, where that gets expensive really, really quickly, and you just don't have the resources to come up with so many possible answers. So instead, the cheaper thing to do are these little, you know, thumbs up, thumbs down buttons at the top right corner over there, where a human can say, hey, that was a good answer. And so when you click these buttons, these are actually really important for training ChatGPT, because you could say, you know, that was a good answer, and ChatGPT will learn from that and will produce similar answers in the future. Now, there's a lot of shortcomings, though, with reinforcement learning, which is part of the reason why it has not been, like, so popular lately. First of all, just like with ChatGPT, you need a ton of trials. And also, the state space can be huge. So, for example, you're not going to be able to model every single possible combination of positions that Pac-Man and all of the ghosts could be in. That just becomes really, really intractable. Also, there will be consequences because, which that sounds vaguely threatening, but what I mean by that is that if you take something like a simulated environment and you apply it to real life, like the self-driving cars that I see around here in San Francisco, you know, chances are that it's going to realize that simulation is not equal to real life, and if it makes a mistake, whereas in a simulation we could say, okay, it just made a mistake, let's just do a new trial. In real life, something bad could actually happen. So, you know, we have to be careful about that. There's also, and this I think is a really cool example, there's also the exploration versus exploitation problem. So with exploitation, that means, hey, what I did was good. I'm going to keep doing that. And the problem with that is that if you exploit 100% of the time and you don't explore, you learn nothing. And so exploration is sort of the opposite problem, where you're like, hey, I don't care that what I just did was good or what I did was bad. I'm going to do something else. And so if you do that 100% of the time, you will also learn nothing. So the example I usually give is with a dog. So if you have a dog, or I was going to say a cat, but they're not really trainable, at least not in my experience. But with a dog, if you have a treat and you tell the dog, sit down, the dog's not going to do anything at first. If you have a puppy, you know, you've tried to train an animal, and it gets no reward. But if it does a little bit of exploration, like it's following your hand, and it decides, you know what, I'm going to sit down, then it gets a treat. And so that treat reinforces that behavior. So exploitation means that if you say, go down, the dog is going to sit down because regardless of whether or not it gets a treat, it knows that in the past it's gotten a reward, so it's just going to keep doing that behavior. Exploration is sort of different because, you know, exploration is a dog is saying, you know, I'm going to just run away or do something else, even though my owner has told me to sit down. And so this is an undesired outcome. And so either no reward could happen, or the owner could yell at the dog or spray it with a ball. I don't know how you discipline your dogs. I don't want to assume anything. But yeah, so the dog will learn eventually, if I am told the command down and I sit down, I am much more likely to get a reward if I obey my owner. And guess what? You have trained your dog using reinforcement learning. And whether you believe it or not, dogs are intelligent creatures. So that's why reinforcement learning does not exactly explain how the brain works, but it is a good way of explaining the psychology behind how intelligent creatures decide which actions to take. The sparse rewards problem is that I was talking about like Pac-Man and dogs, but the truth is you might not get a reward all of the time. And so this is called the sparse reward problem because you have no idea whether the action you're doing is actually good or not. And so that's why there's different techniques in reinforcement learning like Q-learning and stuff like that. And just to give an example, let's say that you're trying to solve a really, really hard TypeScript problem. You're like trying everything and it's still red, it's still yelling at you, and then you just add a generic parameter or something like that, and all of a sudden, all of the red squigglies go away. You're going to remember that, and you're going to say, hey, all of the actions I did to get to that point were probably really good actions. So the next time you encounter a TypeScript error, you're going to repeat those actions. Anyway, so let's get back to state. The realization that I've had, and probably others have had too, are applications, unlike the real world, applications are actually really, really constrained environments. Think about them. We're basically building forms, we're building CRUD apps, of course we're building things that are more advanced, but it all boils down to we have an application which is constrained by the code base. You know, we're not trying to build the metaverse or anything like that. We're building glorified forms. I'm sure some of us are building more than that. But, they have buttons, they have inputs, they have all of these sorts of things. And so we have a discrete, finite list of things that a user could do or that could happen throughout the app. So how could we use this to our advantage and actually make state management intelligent? So there's a few different ways. One of them is adaptive UIs, and there's been many experiments like this in the past. One of them is guest.js, where basically with adaptive UIs, we're predicting what the next user action is going to be. And so we could do things like preload pages. I know that Next.js actually does something similar to this, where it, maybe it's not based on user analytics, but you're actually preloading data so that when you click, it feels instant. And so that's an example of an adaptive UI, and you could go really far with this using predictive analytics. There's also generative AI. There's this really cool project that I saw called E2B, which stands for English 2 bits, and it basically acts like a developer for you where you tell it, I want you to work on this with me. So if you take anything minor from this talk, there's this really cool tool. Don't tell your boss that you're using it, and you could basically have your own pair programmer with you all the time. There's also goal-based agents, and shout out to Steve from builder.io. He showed this off, which is really cool, where you basically tell it a goal, and it figures out the steps based on each step of it's going on a website, it's just scraping, okay, here's the different links that you could click, here's the different fields that you could fill out. On the form, choose the best action that will probably lead me to the state that I want, such as, I guess this is how to adopt a pet, or something like that. But definitely talk to Steve if you see him later today. This was a really, really cool project. And of course, there's AI assistants, and the most famous one, Clippy, way, way ahead of our time. So I've been talking about this a lot, but one of the main ideas that really gets us to intelligent user interfaces and intelligent state management is the fact that everything is a graph, a directed graph specifically. Everything from either your relational databases, your GraphQL relationships, it's a graph, it's a directed graph, and even things like user flows, or one of my favorite things to show, this is the Slack decision tree for whether Slack should send a notification or not. So whether it's implicit or explicit, everything in your application is technically a directed graph. And so I actually experimented with this idea, and I thought, how could we actually make state management intelligent? And so here's a state machine for how I actually tried to accomplish this. So basically we start, this is a state machine, of course, by the way. We start in the idle state, and we get the state space. And so what this means is that we're traversing the application, and we're determining what are all of the possible states that we could end up in, and what are all the transitions that we could lead to. And so from that, we're providing a prompt, and we determine what is the ideal end state. So this is the small part where we're actually using OpenAI, and we're asking it, hey, based on all of these possible end states that we could be in, which state best represents the goal that we could achieve, or sorry, what best represents the end state that represents the goal the best. I'll show you the prompts. I probably butchered that. But from there, we get the shortest path, which has nothing to do with AI. This is purely algorithmic. This is graph algorithms, Dijkstra's shortest path, and we traverse the path, executing each step in the path, and then we achieve that goal. So I'm going to show a demo. Hopefully the Wi-Fi works. In my experience, this demo has worked like 90% of the time, just because that's the nature of ChatGPT. So if it doesn't work, I'm actually glad, because it shows that, I'm not doing any tricks or anything. But basically, this is an espresso machine. It's a very basic espresso machine that I made yesterday. And so you could do a few things. You could start it, grind the beans, they're ground. We could, heat up the water, and now we're tamping the beans, and then it makes an espresso really, really quickly. And then the drink is made, then we could, add a few things, or we could just restart it. So I'm going to reload this. And so that's our basic machine. Now, in this, I'm going to press Command-Shift-F, and I'm going to search for the word cappuccino, if I could spell it right. You could barely see that, but over here it says no results found. And so this is important because this app actually operates on a state machine. So this entire espresso machine, aptly called, is a state machine, and I have it over here. You can't really see it that well, but we have all the steps here. We have idle, then we could grind the beans, and then the other steps just show that you could add different ingredients to it, but it's all a step-by-step process. You can't just say, oh, here's all of the ingredients, this, that, now you have your drink. You actually have to go through all the steps as if it were a real automated espresso machine. So what I'm going to do is I have this agent.ts file, and by the way, playing around with OpenAI is really, really fun. And so if you're scared to try it, it's actually one of the lowest learning curves. Actually, I would say the highest learning curve is actually figuring out the prompt. The prompt is, probably the biggest trial and error type of thing. But what I did was, I got the shortest paths. I have the prompt over here, and I'm asking ChatGPT. First, I'm telling it, you are a helpful AI assistant that is good at classification and knows how to make coffee. I probably didn't need to add that. And so I say, if I want to achieve this goal, and then I include the prompt, which one of the following end states matches that goal best? Only choose one. At times, it would choose two. It would mess things up, so I had to be really precise over there. And so it basically finds which one. If there is one, sometimes it will error with no key. And then I execute each step. All right, so like I said, I'm going to ask it, make me a cappuccino. And hopefully, it's going out to ChatGPT. And then it will execute the steps. Sometimes it gives funny results, so we'll see what happens here. And all right, it did the espresso. It's steaming some milk. The milk is steamed. It's combining it. It added cream for some reason, but there you go. There's your creamy cappuccino. Thank you. And just to prove we could do other things like Americano. Again, this is not in the code base at all. But yeah, so it is going to just find all of the steps, traversing the state machine in order to add the proper ingredients to make the Americano. And yeah. So I was pessimistic, so I added a video demo over here, which we're not going to go through. But I have 2 minutes left, so let's go through this. There's a lot of future things that we could do from this. One of them is called state machine synthesis. And what this means is that you don't have to write a state machine. You could basically say, here's my legacy code, here's my app, please traverse it, figure out the state space, and from there, figure out what all of the transitions are without me having to do so. That is possible. It's already there's many papers on it, so it's something that I'm excited to experiment with. And also, how does reinforcement learning play into all of this? Well, paired with state machine synthesis, we could say this is a probable state machine of how your application works, but if the agent encounters like, oh, hey, this was an unexpected state, then we could say, you know what, go back there. That probably is something that you should adjust the weights to so that you could go to a different transition and realize that when the user tries to do a goal again, they're probably going to want to choose a different path. So there is that. Predictable LLM output. There's this cool tool that actually just came out yesterday called JSON Former, which says, here's a JSON schema that I want you to adhere to. Please, try to make that work. And also deep learning for state space reduction, because again, the state space could get huge. I have a minute left, so I'm just going to breeze through these slides. I talked about reinforcement learning with state machines and how state machines are really useful for reinforcement learning. This is actually pretty cool because the different ghosts actually exhibit different behaviors. I could talk a lot more about that. But one more thing, this is another paper that recently came out. Atari is usually used for, in OpenAI's Gym and things like that for evaluating reinforcement learning agents. And so one of the most recent advancements is that actually pretty funny. One of the most recent advancements that came out is that this research team was able to dramatically reduce the number of trials that an agent can do to learn and to exceed human behavior in Atari games like this one. How did it do it? Just by reading the instructions. So it took the instructions, which serves as that declarative model of these games, and it was able to actually predictably make moves instead of just guessing and doing random moves. And so, believe it or not, reading the instructions is a very important progression in AI. So I have 4 learnings for you. First of all, large language models are unpredictable. Declarative logic is really, really useful. I believe that reinforcement learning gives us insights for artificial general intelligence, and graphs make many, many things possible. Some people might think that AGI is coming soon. Others may think it's coming many years away. In my opinion, right now, think of AGI as a marketing term. We're still many years away from it, and language, even though it plays an important role in intelligence, there is so much more that goes into intelligence than just language. I mean, just look at robotics, look at these autonomous agents, look at your pets. They don't talk to you. You talk to them, but they don't talk to you, But yeah. And the other big thing is that, in React and in application development, there's basically what I would call 2 truths that come to state, or with regard to state. First of all, it's that your UI is a function of your state, and that reality really belongs to your UI framework, whether it's React, Vue, Next, Angular. And the second one is that the state, so whatever that state that is consumed by your UI framework, it is a result of the previous state and the events that change the state. And those 2 things can really communicate with each other. And the reason that I talk about this is that in the sense of making your application logic intelligent, keeping those 2 things separated make it a lot easier for you to build these intelligent applications and to use things like LLMs and ChatGPT to actually do things. So, by the way, I will quickly plug, we just released Xstate version 5 beta, so if you're using it, please give it a try. Yeah, so again, the 2 takes that I really want to share, and sorry that I'm out of time, is first of all, your state management. I believe that you should separate your app logic from your view logic. Why? Just because it's going to make it easier to do a lot of really, really cool things, like I showed you with, with your state. And with intelligence, I believe that the best way to apply AI to your applications is as minimally as possible. You're writing software. You want your software to be declarative. You want it to be predictable, explainable, and you want to give your users a good experience. And yeah, so with all of that said, thank you so much, Reactathon.
Great. Thank you, David. You know, he's right about cats. They really can't be trained. If anything, as a testament to that, is my cat, 4 a.m., favorite time to paw things, make noise, knock stuff off the counter. Fantastic. So anyways, you may have noticed that Jem's not here, so you're stuck with me. For those of you who got to experience some of his dad jokes earlier, sadly we're missing out on that, but fear not, I have some for you. I'm not a comedian, so I asked ChatGPT to help. It is not only a productivity tool, but an introvert's best friend, so bear with me. This is interactive, so I'm going to shout out a question, and then if anyone has a guess, let me know. So, why do programmers like dark mode? That's not an answer. Any thoughts? Okay. Because light attracts bugs, but yeah. All right, here's the second one. Why was the computer cold? No one? Okay. Because it left its windows open. Yeah. So I'm sure most of us work on a Mac, so you know, it's not always super relevant, but you know, here we are. And let me tell you, that was maybe 2 of the good ones out of the 10 jokes I asked it to produce for me. So you know, we're a long way from the robots taking over. But how many of you have asked ChatGPT to do something for you, be it creative, productive? Yeah? Who here is writing their emails with ChatGPT? Yeah, it's good stuff. It's pretty interesting though, like David's talk brought up a good point too about how a lot of times, you know, the AI we work with takes in a series of inputs, produces a set of outputs, but getting it to actually achieve a goal can be a little bit more difficult. So in my own experience, one thing that's been interesting is in order to get it to do something productive, creative, you know, the goal you're trying to achieve, it actually takes a lot of questions sometimes and iteration and asking it the right questions, the right way, you know, et cetera, et cetera. So it does kind of also make you think, like, how much different is, you know, just asking questions in a, you know, sort of human readable way, that much different than programming? Just something to think about. You have to sort of figure out the right skills. You have to have the right skills in order to ask the questions that you need to get to the answer that you're looking for. Something to think about. So anyways, please welcome back Benjamin Dunphy and his guests Sean Grove and Sean Swix Wang.
Yeah, it's a little difficult to get to our seats here. All right. How's everyone doing? Yeah, that kind of 4 p.m., 4:20, as Elon Musk would be fond to hear. It's extremely exciting to have this session and make it feel like it makes sense. AI talk, discussion at a React conference. Because it feels like there's something in the air here. It feels like we're at an inflection point. These technologies, you know, the majority of us are working with them already. GitHub Copilot, ChatGPT, we all recognize the potential. But I'm so excited about this, I'm skipping your intros. So I am joined by Sean Grove and Sean Swix Wang, who I would refer to as Swix. Sean is the founder at OneGraph, acquired by Netlify, where he now works as a principal architect. He has experience not only in JavaScript, GraphQL, many other technologies, but also Rust, Reason, Rescript, and OCaml. And Swix, you all know him. He's a legend in so many areas. He's worked a lot with React as a DevRel at Netlify back in the day. Has done cloud infrastructure at AWS and Temporal, and served as head of developer experience at Airbyte, where he dove into cloud and data infrastructure. But you probably know him best for his excellent Twitter posts and his writing at dx.tips, or from his new blog and podcast focused on AI, Latent Space, which I believe is latent.space, the TLD?
It's a cool domain.
Excellent, yeah, excellent domain.
You want to guess how much it was? It was $500, but yeah.
So let's dive into that. Let's dive into this inflection point, because most of us here are front-end devs, but I think we all recognize that something special is happening. So GitHub Copilot, ChatGPT, these technologies are on just a whole different level. So Swix, you've recently gone all in on AI. But before we get to the current state of the art, can you help us to set some context? Just to give us a little bit of history. How exactly did we get to this point?
Yeah, so we prepped this a little bit, and I sent over some charts. Are we able to put it up on the screen, or?
Sure.
Are we going to
Can I go full?
riff it?
Can we get the screen?
Because I feel like this is my way of not having slides. I just kind of tweet out some pictures and and try to kind of go from there. And I think everyone needs to have a little bit of sense of AI progress. Yeah, so I think what is important for everyone to know is, or myself to know, which is why I've chosen to go deep on it, is this something I've been watching for a while. And I think it's something that has been in the undercurrent of a lot of the development that we produce. Even in the 1940s and 1950s, the way that Alan Turing thought about his machine was, he was very much thinking about the imitation game, and the Turing test is already in the sort of World War II period, thinking about how machines can imitate humans, think like humans, potentially beat humans, and he successfully did. Arguably contributed to shortening the World War by several years. And I think that amount of progress has just industrialized over the past half century, and it's something that we should put ourselves in historical context and seeing ourselves as part of a larger story. So what I have up here is just a chart. For those who can't see on the screen, it's from our world in data. I think it's probably the single best collection of timeline historical charts that you should have a grounding knowledge of. And this chart's just the evolution of compute from large mainframes down to microprocessors and personal computing down to phones, and then artificial intelligence systems from the earliest models up to AlexNet, which is the way that we dove into that we went from traditional machine learning into deep learning, where we basically lose all control of like what is inside of the hidden layers. And then more recently in the 2000s, 10s, and 20s, having human-level benchmarks that each of these models increasingly match and exceed human capabilities on. One of these I really like visually. I actually used to have this up as my Twitter banner for a long, long time. This is the Moore's law of our era. When Gordon Moore was talking about RIP, by the way, when Gordon Moore was talking about progress for semiconductors, I think that sort of scale of exponential evolution is happening in generative AI and language models and just reasoning and automated reasoning in general. And you can kind of see that the state of the art over the past 9 years has progressed tremendously, and we now take, as a matter of fact, with a $8 machine Midjourney subscription, something that was completely inconceivable in 2014.
Yeah, I remember the 2017 image there, just being blown away. Like,
oh yeah.
As a developer, I was like, I have no idea how you would do that. How would you would manually program that?
Yeah.
And now it's quaint.
Yeah. It's cute. Yeah, yeah. And
this person doesn't exist. I think that was blowing up.
Oh yes.
Yeah. Final chart, because I don't want to turn this into a slide deck. There's an overwhelming amount of research coming out. Even the machine learning researchers are overwhelmed, so don't feel like you're alone or left out. Everyone's trying to figure out how to stay afloat in this journey. But I have more charts, but that's just the brief history of the past few decades.
And not just overwhelmed, as you said, these researchers, these PhDs, these people who have been doing this for decades. Mm-hmm. They apparently don't even understand how these things are working. According to this podcast I'm listening to, it's like mind games. I should have remembered it. But it's a fantastic podcast where they're interviewing people who have been doing these technologies for decades. And they're saying, we still don't understand how they work. I'm getting ahead of myself here, but Sean, can you tell me, you decided to read a research paper every day. What was it, starting last November or so?
In January, yeah.
In January. And so you've been getting a lot into this. So what is your general take on these technologies, LLMs, and basically everything adjacent to that.
Yeah, I think there's a lot to consider. One is just kind of how useful they are for us even today, and then also, to Sean's point, kind of the rate of change. And those are like two separate concerns, but both interesting. The first of which is, things like Copilot are pretty magical. I hacked with a friend who visited from out of the States, and he wanted to work on a side project. And I told him, I'm not going to work with you unless you install Copilot. And, he's been in, hadn't heard of it. So he installed it.
Yeah.
And it was, the blood left his face. He really, this is amazing. And that is already kind of quaint technology.
Sure.
So kind of the rate at which it's able to help us, and I think we'll see this pop up in a lot of different places. This is kind of one early experiment I did with a PR bot powered by GPT-4.
Do you want to play it? Or?
Yeah, sure. Yeah, so, this is like, I have this, I get worked whenever, I have a PR up and someone asks me, hey, can you change something? And it's like, hey, you were right there. Maybe you could have used the suggest the commit button. So in this case, I've changed, this is a contrived demo, but I've gone from expect error to ignore, and there are a lot of other expect errors. And so maybe someone asks me, hey, can you change it elsewhere as well? And so I just wrote a little GitHub bot, and what it does is it gets first crack at any GitHub comment. So in this case, it gets this comment, and then it's going to actually react on that. I chain a couple of prompts together, I go out and I grab all the relevant files, and then it actually provides me with a suggestion. So in this case, it's actually gone through and said, well, I think this is what this person is asking for. And as a human, I'm still involved in a loop, right? I get to say, yeah, this looks good, or not. Maybe I'll go ahead and just implement it myself. But kind of this idea that you can imagine that this is like natural for GitHub to implement inside of their product, right? Like, I suspect that this is going to start popping up in all sorts of places where it already helps automate the job that we do today. And then I think that the next step is kind of like, if you think about, well, how good was Copilot when it first came out? How good is it today? And how good is it going to be next year? Especially if it's kind of combined with some of these automated PR tools and whatnot. I think it has like really big implications as far as how we position ourselves in terms of the skill sets and whatnot.
And this is leveraging the ChatGPT
exactly, yep.
API.
Yeah.
And just so we're not assuming the level of the audience here, can we talk very briefly about what an LLM actually is? Yeah. I mean, well, like I just said, no one understands it, but like the basic principle.
Yeah, so it's the motivation behind the original kind of design of these is incredibly simple. The idea is you're fed a string of like, I want to, and all it's trying to do is guess the next word, or the next token, but we can just say word. And it's actually, initially it was trained off of some fairly large corpus of data, maybe a bunch of Amazon reviews, something along those lines. And it turns out that in order to kind of statistically match the underlying data, and therefore to get a good reward, it actually kind of needs to build an internal model of a lot of different parts of language and also human psychology. So as an example, there's a fantastic blog post from OpenAI in 2017 where they had achieved pretty good, it's kind of GPT-2 times. And they had achieved pretty good text output using this just prediction model. But when they went in to kind of dissect this model, they found out that they actually had a single neuron inside of the model that accurately predicted sentiment. So kind of sentiment analysis, which is a fairly advanced topic in computer science. And it beat all of the state-of-the-art approaches. And so, like, and they kind of
single neuron. And can you just focus in on that for 1 second? Mm-hmm. What exactly is a neuron within the context here?
Okay, so large language models are neural networks. So the idea is you have a set of activations, inputs at the top layer. They have weights that connect them to subsequent layers. And so when one gets activated, maybe its connection to the subsequent one is activated at half or double. And this continues for a while. This deep learning is kind of referencing we have lots and lots of these layers. And finally, at the output, it's outputting some results. And then based off of the output, you say, all right, you scored a C or a C+, and you then kind of propagate that back up there and you adjust the weights based off of how well it did. So if you said like, hey, you got an A on this, reward everybody by increasing the current strength.
Interesting. Yeah. I like that.
Yes. So so inside of that, so to your point, they're trying to figure out like why does this work? Why are we able to generate this? And so they overlaid kind of the expected sentiment in like between bright green and bright red, if it's very negative or very, very positive. And you can kind of see the sentiment change over the paragraph of, say, the Amazon reviews. And so it had to learn this concept of sentiment because that helped it actually be much more accurate and get much more reward in the process. So kind of this deeply fascinating thing where without explicitly teaching it about sentiment, it had learned it.
Mm-hmm. Do you want to pull something up?
Yeah. Is it?
Yeah.
I just wanted to recommend a talk for people to follow. I can't, this is not working.
What's happening?
There is, yeah, which is, it's interesting.
What do you need to do?
That if you just throw enough data at anything, it eventually solves it. Yeah, so I think there's a talk called Transformers, like long-lived Transformers or something like that, which kind of goes through this evolution in more detail than we have time for.
Yeah, and I suppose the GPT is a transformer model, and it is kind of it's underlying a lot of these different things. It was a pretty important discovery by Google, I think, in 2015.
Mm-hmm. And then they open sourced it.
Yeah, they wrote a paper about it. Yeah.
Mm-hmm.
Attention is all you need. Yeah.
Exactly. The title was "Attention is all you need," and it was it's normal in research to publish your papers. In fact, you are strongly encouraged to publish your papers. So people have kind of, I think, unfairly criticized Google for giving this away. Like, they didn't realize what it was at the time. Like, it seemed to be very effective. Like, it's a normal thing to give away.
Mm-hmm. So how is this, so you showed an interesting example of using this in pull requests. How else is this affecting our lives as developers?
Oh, wow. So many ways. I am actually...
Let's focus in on one.
I'm very obsessed with the ChatGPT code interpreter plugin right now, which I think there's been a few modes of programming in the history of programming. I think we have the text editor, and then we evolved the IDE. Then we had a notebook, the concept of a notebook come along for Python. And I think a lot of us occasionally get sucked into the literate programming world where we want the thing that we work on to also be the living document that is live. The code interpreter plugin is a new type of programming where you're having a conversation with a bot that is working on the program and running it and executing it. And Sean actually has a demo, I think, of where I think his main point is that there's a lot of custom code that we're doing that is essentially just boilerplate, and you could just kind of describe it in natural language, but beyond that, beyond just having the idea, the execution and implementation actually is not very valuable. We could just do that automatically. And something like, I think you have some kind of estimate, like 50% of our code is ephemeral throwaway, and we actually don't do a lot of that work because it would take so much effort, but now that we have a bot to just talk to and produce what we want, that work is going to get done. And I think that's going to unlock a lot of productivity. You can
We have to show the demo.
Yeah. Is that Conjure?
Yeah, Conjure, yeah. Okay. So the idea behind this demo is,
No sound.
No sound. The original motivation is kind of, if you imagine if something like Siri actually worked, how many different UIs do you need at that point? And I say, if you could reliably use Siri, then something like maybe 40% of the UIs that we tend to use, maybe low frequency, would kind of go away.
Could you unpack that a little?
Yeah, so it's like a shopping to-do list or a shopping list, right? A typical thing that we might develop. Even Alexa is already kind of reasonably good at saying, hey, add this to my shopping list. So kind of things around there where you kind of set it and forget it, and you need data retrieval for later, or maybe a small factoid or something along those lines. There are a lot of individual one-off apps that just tend to go away. We just don't need them. Or UIs, I should say. APIs remain very important, where it can go and read data or make effects and write to the world. But then there are lots of one-off tasks. So in this case, I'm going to ask and I should say, this is an open source version of the UI of ChatGPT, where you can go in and you can kind of hack it, you plug in your OpenAI key, and then you can pick the model underneath the hood for what you want to actually use. And so in this case, I'm saying, hey, I want an interactive, sortable, searchable table with the top 10 most popular fruits. And this is sped up. That's the only part of this that is not real, because it is very slow. There's a lot of prompts.
We do this in cooking shows, like, ta-da, I already baked for 4 hours.
Ta-da.
But you can see here, it actually has written a React-powered app. So it went out and found the top 10 most popular fruits, included their nutritional facts. I can search, filter.
So it's creating this entire UI.
Exactly. So it's kind of, you can imagine like maybe a more progressive version of this is where you get some data back and you realize, you know what, I'm having a hard time kind of visualizing this. Maybe I want to be able to sort of filter it. And it creates a new little UI for you, and you say, well, actually, I also want some pictures, or maybe I want to know, like, give me a map of where they're actually popular. And it kind of creates a UI on the fly, and then remixes itself, kind of modifies itself in place. You either are satisfied with the data, or you know, maybe it's you're trying to figure out where to fly, or something along those lines. So you achieve the effect. You book the flight, or whatever it might be, and you've done the thing you need to do. This UI has fulfilled its purpose, and is released, and it just kind of goes away.
Conjure an ephemeral UI.
Exactly.
So it
You
seems like
thank it for
taking-
its service, and then you give it away because it's spark joy.
Yeah, and it's you know it's kind of interesting because you know as the cost of creating these UIs actually approaches zero, you get lots of novel UIs that like you would feel bad asking someone to make a little weather app that you specifically needed to take part of their life and say, hey, I'm just going to use this for 5 minutes, but can you sit down and write me a React component that does these 5, 6 different things? You think, no, I'll just go and do the manual version. But if the cost of producing these, this is a great example, but if the cost of producing these is close to zero, and that's, you know, like I said, that was sped up, but kind of given the rate of change right now, I think both the speed and the capabilities will be like markedly different, even just next year. And so what you can create and the cost of it just approaches zero. The exception to this, I think, so I would say, you know, the kind of chat interface, the assistant approach, is maybe 40% of UIs go away. Maybe another 50% are kind of created on the fly using some substrate. And there are probably something like 10% that will actually be built the way that we work today, kind of artisanal, handcrafted UIs. You know,
Do you see this for consumers, though? Because oftentimes, as Steve Jobs famously said, customers don't know what they want, right? You want to get them into a funnel, guide them through a process. Do you see that as a speed bump to this beautiful theory of yours?
I suspect that we're already seeing kind of the effect of this with ChatGPT plugins, where actually the interface is that it's making the existing interface like kind of the core, and most of the UI aspects are just controlled by this single window. I think the only cases where we actually have this artisanal hand-built UI, you know, after some number of years, call it 3, 4, 5 years, maybe 10, is where it's a very, very frequently used app, and even a marginal benefit is worth a high investment. So I might think of something like the Bloomberg terminals, where they have custom keyboards and whatnot, because even if it takes you a year to learn this, like that directly translates into more money. But outside of that, you know, there will be some subset of familiar widgets, from which like these UIs will be composed of on the fly. You will do your thing and move on.
So you're talking to a number of very senior engineers that work at very respected companies right now. So what do you say to them if we're saying that these technologies, these front ends are going to be entirely written by this? Is the code quality going to be comparable, or does it not matter as long as it works?
I think it's messy. I would probably fall on the size of, so right now, one of the biggest limiting factors is the context window size. So that's kind of what you can put in the prompt. And that's right now, that's the main way that you kind of tweak these models. There are things like fine tuning and other things you can do, but the way most people are going to consume these models is by kind of hacking the prompt. And so you're really limited by what you can fit in that prompt space. And as those context windows gets larger, the capabilities are actually going, I think, to become, they're going to emerge in a non-linear way. They're going to like really, really grow. So in that case, it's like, well, do I actually care about a PR, like what code was actually changed? Maybe what I care about is like, why are you confident, you know, GPT, you wrote this change, why are you confident that this is going to work? So maybe I care about kind of the artifacts that are generated around it, so the visual tests, the unit tests, or whatever might be, that like, I'm not maintaining this code anymore. You're maintaining this code. And as long as you can prove to me that this change has achieved what you expect and not some side effect, then I'm fine with it.
So it's all about the outcome. Swix, like, what are your thoughts on that? Like, are there any other tools that we can use to really expand this and go beyond the token limits that you mentioned that are going to expand, like things like LangChain, are there any other technologies in the landscape that are going to really increase the productivity here and drive this art forward?
Yeah. It's really hard to say. So there are a lot of techniques. Actually, LangChain does, I think, weekly webinars where they gather together the people working on the state of the art of these things, and they do little presentations. Highly recommend them, even though they don't use YouTube. And I'm a YouTube maxi. Everything should be on YouTube. But anyway, that's their choice. But they have techniques around packing of prompts, packing more and more stuff into context. I think ultimately all those things are more or less just short-term improvements on the state of the art, and context will improve over time. You know, GPT, the standard right now is at 4,000. We're going to 8,000. GPT-4 goes up to 32,000, which they're starting to roll out to people, and I'm very jealous because they don't have access.
There's a paper the other day on RMT, which is kind of
1 million tokens. Yeah.
Up to million.
So eventually it'll just go away, and I think
what will just go away?
This context limitation.
Yeah.
You would just dump entire.
Yeah, imagine
docs,
like with
code bases.
Copilot, you just sent over your entire code base on every keystroke, and you're like, hey, what do you think I should type next? Right? Like it would have a much better recommendation versus right now where they have to be very smart about what they send over.
And where is this source coming from?
So if you're using Copilot, but right now what they do is they're very cleverly trying to figure out like what should we send over to the LLM in order to ask for a recommendation. And what if they didn't have to be clever and they could just send over the 200 most recent files?
So we're talking about GitHub Copilot in particular.
Exactly.
Okay.
So you know, this is not what they're working on, I don't think, but you can imagine a world where they have access to this, right? These models have regressed, and probably relatively soon, and so the quality of prediction then probably goes up significantly better. It's like if you had great memory of all 200 files at any given time.
Yeah. For reference, if anyone doesn't know, Copilot has been reversed to some extent. So someone actually decompiled the VS Code extension. So you can actually kind of look through what they send. They send over 20
They
files.
reverse engineered it and open sourced it? Is that what you said?
Reverse engineered it.
We're
not sure about the open sourcing and the
Okay,
licensing and all that,
got
but it's out there if you want to see it. It's 20 files. It's not 200 files. Therefore, Copilot doesn't have full visibility of your code base, and eventually it will. And we should hope for that future, live for it. I'm actually, my podcast today just released the model from Replit, where they do have a pretty significant understanding of your code base. I don't actually know how they do it. They don't talk about it. But it seems to be a better implementation than Copilots, which is fascinating.
Yeah, and for such a small team, and like things are moving so quickly, so even small teams.
2 people train that large language model. It's very accessible.
Yes, I actually think that's like part of the message today. Is like the skill sets we have, they're valuable today, but they will change radically in a short period of time. But it's also really exciting. So it's kind of terrifying in some ways, right? It's hard to know how to keep up. On the other hand, like it's really exciting because small teams can do so much.
It seems to me that it's not necessarily the changing in technologies that you need to be versed in, but it's the velocity that I think is scaring people. The pace of the change is just so fast, and things are happening so quickly that you see one thing on Twitter, and then the next week it's old news.
There was a pause letter, by
Yes.
Steger and Elon Musk on it saying, hey, we should pause for 6 months. And the joke is that actually that was just everyone working in machine learning saying, hey, we need a vacation. Like, we just need a pause. We just need a break.
It seemed to me more like it was we want the competitive advantage.
No, you could
Facebook calling to be regulated for all social networks.
Yeah, you could imagine something along those lines, yeah.
Yeah, I don't know. What do you think about that?
The pause letter?
The pause letter, yeah.
Complete joke.
Okay,
Yeah.
why?
It wasn't never going to work. Everyone signing it knew it wasn't going to work. It's just a PR stunt.
I think in particular, so, one way that people are looking at these models is, and the capabilities that emerge. So one thing that's interesting is kind of emergent behavior, where, so Google has its new model PaLM, and they have 3 different sizes, 8 billion parameters, 60 billion parameters, and 560 billion parameters. And what they found is that, on some tasks, it was not very good at 8, it was not very good at 60 billion, and at 560 billion, it was suddenly great. And another one where, it was not very good at 8, it was suddenly very good at 60, and not much better at 560. And kind of, naively, from my point of view, I was surprised, because you kind of expect maybe a linear improvement. But it seems like, at one point, these models get big enough to actually incorporate some new fact, and some new model, and so they get something better. But then there's an alternative, which is chinchilla models, where you train on less data for much longer, and they're actually getting fantastic results. So you can imagine in this, the letter calling to pause things was saying, hey, no runs on models larger than GPT-4. But in that case, a lot of energy is going to go into extracting much more value out of the models that we already have.
Sure, and something like that is impossible to enforce, or even police.
It's very difficult to even specify what you mean.
Exactly. Yeah, yeah. Interesting. So how do we keep a positive message here? What do we tell people that are fearful of their jobs? What is the future of software engineering? Not just front-end engineering, but software engineering. Ultimately, the structure of how we ship product, how we deliver value to the market. Is everything changing? Is this going to be a paradigmatic shift that we look back and say that was the moment that it all changed?
Is that on me? Okay, all right.
It's open. I was looking at you when I said it.
So a few points. One, many of us currently hold jobs that did not exist 10 years ago. We will hold jobs that will be created in the next 10 years because the human creativity and desire for more things, faster, better, cheaper, freer, open sourcer is infinite. And no matter how much capacity we throw into machines to replace all that, we will want more and more and more. And two, I think one of my favorite quotes about technology, how I think about technology, is that civilization advances by the number of operations that we can do without thinking about it. And that's Alfred North Whitehead, who said that in, I think, the 40s, and it still holds true today. So we just, as long as we solve this tier of abstraction, we kind of go higher. And I think, last one, I'll have a carve-out for UI and React people. To the extent that all this GPT stuff is replacing jobs, it's actually replacing back-end jobs. A lot of times you can just kind of, a lot of the discovery of people implementing these things in production systems is that you can actually just kind of have GPT kind of mock a backend without actually writing any implementation of it whatsoever. That's the project is called Backend is All You Need, and it won the Scale AI Hackathon recently.
Okay.
But
So
people will differentiate
not
based on...
Googleable easily?
Sorry?
Not Googleable easily on stage? Just a hackathon project?
Yeah, you just type backend is all you need for GPT. I know it's a super long name, but it was a hackathon project. They didn't come up with anything
Well, this
else.
is a 2019 MacBook, so I dare not type on it.
But I think there is a space for AI UX, is what I'm calling it. We had a meetup at Notion HQ a couple weeks ago, and there will always be demand for more human interfaces to these machines, to these omnipotent creatures. We need to sort of give affordances to these new paradigms that let us control them and align them the way that we do things the way that we want them to be done. Chat is just the beginning. There will be more ways to interact with these.
I think about it a little bit differently. So, I think it's reasonable to be nervous about how are we going to be able to contribute value. But I think the best way is to push forward, not kind of hold back.
Sure.
And so if I enumerate all of the things that I think I'm skilled at and I'm able to contribute value in, my approach has been using these tools, which are really like cheat codes. It's just I've been able to build such fun things, is to try to automate all of my skills, try to make myself obsolete. And kind of in the process of that, it requires that you think differently, that you kind of move up one level of abstraction. You no longer have to think about the actual code, maybe underlying, your PR or whatever. Not that we're there today, but you can imagine at that state, maybe society has progressed forward to some degree, right? We no longer need to think about that, the actual code. We can think about the actual observable changes. So I've been, and kind of in that process, as you try to automate your own skill set, as you use these tools and try to learn how they work together, you discover new things that you can do, and it's incredibly energizing. So
I was just on that point. I was trying to find a tweet from Nader Dabit, who was talking about the positivity around these technologies. He says, I put out a YouTube video just showing he built something simple with these technologies, and he said, I got like 10 job offers. People asked me to come and train and come and speak and like do all these things. And he's like, just work with these technologies and put something out there, and you're going to be fine.
Yeah,
so
really.
I think if people are worried, then to your point, work with the damn stuff, automate yourself, help others automate others, and then we just elevate everyone together.
Yeah, exactly. So kind of to that point, I've done a lot of different hacks and whatnot. And I read a paper on the reflection technique, and the breadth of machine learning papers right now is huge. So there's some stuff from Google where they're talking about their 560 billion parameter LLM and how they scaled it using custom TPUs with optical. It's just incredibly intense engineering, and they get a 7% performance increase across the tests. And another one called the reflection technique, where you ask the model for an answer, and then you say, do you think that was a good answer? And it's like, oh, you know what? I'm going to improve it. And that gets you like 12% performance increase. So like the breadth of papers is just like surprising, that where even something as simple as this gets like a name and like actually
a paper.
A paper. Yeah.
A lot of citations. Yes.
So this is a little project where I like talks, but maybe I don't like writing them or even giving them. So I wrote a little thing where I can just kind of give the abstract of a talk and also describe an audience. And in the process of it, there's an author GPT bot and a audience GPT bot. And the author comes up with brainstorms and outline and then starts writing the paper or writing the talk. But it has to pass it to the audience talk, who is kind of, it says, hey, you're a Reactathon audience member, you have these skill sets, you're interested in these kind of things. And so whenever the author hands it over, the audience will actually critique it and say, well, it'd be more interesting if you did this, I prefer this.
Yeah.
And so the author bot is not allowed to progress until the audience bot has become satisfied with this. And they just go through this, and then eventually there's the whole thing is done. And that has to be approved by the audience bot. And so you can see here that it's actually incorporated, so the author bot has incorporated the feedback from the audience bot, in this case, kind of automatically. And you can see at this point, the audience bot is happy. It says, all right, I accept this bit. You may proceed to the next bit of the talk. And so this goes on for a while. It's using GPT-4. Also,
this is real time. It's going back and forth.
Exactly. And I would also kind of caution anyone, like if you've used GPT 3.5, GPT-4 is an entirely different beast in terms of what it's capable of. Yeah. It is orders of magnitude better, I would argue. All right, so in this case, it has accepted the talk. It's happy with it. And then it gets to the next part, which is, maybe I actually
Hello, fellow React enthusiasts.
I don't want to actually give the talk. So I use the tool to generate my voice.
It's a pleasure to be here with such a diverse group of developers, ranging from the I just heard about React last week to the I literally invented React type. Allow me to introduce myself. I'm a tech speaker who loves development as much as I love a good dad joke.
So you sound like the Mark Zuckerberg version of Sean Grove and
More
this bot
charismatic.
version.
Yeah.
Yes, but the idea is like this, all I did was describe the talk in the audience. It wrote everything and then generated my voice. And it's nowhere near 100% perfect at all right now. Like there's still a human edge to this, but it's only going to get better from here.
Yeah.
And this is like, I did this before the Drake and the Weeknd song that went viral throughout the internet. So it's probably significantly less.
Just needed a trap beat.
Yeah.
And then,
Yeah.
Well, so my reductionist take on what you just done is you have rediscovered pair programming, which is I like that there's something surprisingly human about how what these learnings have been in dealing with language models, because a lot of them are just like good parenting, good executive communication, and good pair programming.
Yeah. So, and it's actually kind of interesting because when we talk about like prompt engineering, which I think is a slightly silly term, but what's kind of happening in that, where you ask a question, you get a result back that's not quite what you want, and you iterate through it, you're actually kind of clarifying your own thoughts. Like, what is it that you want, and you're walking down the specification, which is generally the difficult part of programming. It's like kind of concisely expressing all of the restrictions and the goals.
Yeah. It's almost like a mix between engineering and writing, though, because writing also helps you to clarify your thought process and help you think. I think, was it you that wrote an article about writing to help you think?
Yeah. Well, many people.
Yeah. Yes, I mean, that's a well-known concept.
So for those people in the audience who want to go deeper on this, the way that you talk about this in machine learning lingo is that you're externalizing the internal sequence of thoughts. And so there are many patterns that have been discovered that cover this. Let's think step by step is the first one of them. Like the are you sure is all you need is my reductive explanation of that reflection paper that you talked about. But really, like, I don't know. Basically, I think the most important paper that people should think about actually is the Cicero paper from Meta, where they basically beat diplomacy players. Diplomacy is a 7-player natural language political war game that is fought between human and now AI players, where you can lie and promise and negotiate and bargain and do all sorts of stuff, but then you sort of try to beat human players at that. Noam Brown actually beat humans. And his insight was that you actually, people have been overemphasizing pre-training and inference time. Pre-training and training time. And you can actually get something on the order of 10,000 times the performance if you for every second of time that you spend in inference time. So essentially, instead of spending all the time in just running your pre-trained model, spending more time in the inference by doing things like externalizing your chain of thought. And I think that insight is actually really good, and it maps the human intuition that, hey, you should, in order to know what you think, you should write it out. And then based on what you've just written out, you can then self-critique it instead of having to do all that in a single step internally inside of your head.
Yeah. You've both been thinking about this for a decent amount of time, relatively speaking to I would just venture a guess, the majority of people in this room. How are you planning the next 5 years of your career? Or the next 2? I don't know. Whatever timeline you want. The future for Swix and Sean.
Yeah.
How are you planning?
Right now, just reading a lot and talking to a lot of people in the space. I have moved to San Francisco against my will in order to immerse, because I do think that there is a very strong centralizing force both in machines and in humans where AI is concerned. I am tinkering with a lot of side projects and hoping to start a company of my own in that space, but don't have anything to plug or share. I do think that learning in public which is the sort of technique that I am known for, that I adopted from Kelsey Hightower and others before him, is a very good learning strategy for literally anything, and I'm doing that with what I'm doing now. And by being relatively open with my notes and by being able to talk and amplify other people as they work on this field, I think I'm learning faster than I could on my own, and I encourage other people to do the same.
Yeah, and your work is not just found on your new blog, Latent Space, and your new podcast, Latent Space, but it's also on GitHub. You have the Swix Brain.
Yes.
Right, yeah. So that's all open source. So you've basically taken that commercial open source idea and just, well, you haven't commercialized that. Yet, anyway. Greatest Swix LLM. Chat with Swix anytime.
No, I think, I think there's, what's important as well, like, there's just way too much for a single person to cover, even for someone who, like, I'm full-time on this right now. So I think you should focus on topic areas which you think have high potential, or you have high affinity to, just based on your prior backgrounds, and just focus on that, and be okay with the fact that you are not going to be state-of-the-art on the other stuff, but just, choose a domain, plant a flag.
All right.
Yeah, I think I would think about it slightly differently. I think the reading is extremely important, just to get a sense of the breadth, but also going deep and build. Like, I would just emphasize build. And this stuff it's like a cheat code. I built one of the things I wanted to do is I wanted to journal. I have terrible self-discipline, and so like I know I'm not going to be able to make myself sit down and write out my thoughts kind of on a white piece of paper. And so I built a little GPT bot using Whisper where I can actually just talk to it.
And Whisper, just for those who don't know?
Oh, so Whisper is another open source model that OpenAI released that is state of the art at turning speech into text. And you can also, there's like a React component called Use Whisper, I believe, which is great. And literally, you just put it in, and you can now talk to your app.
And this is much better than your average
Browser speech.
telemarketer.
There's a speech recognition API in the browser.
Yeah.
No one's using it.
Yeah, this thing is phenomenal. And I actually think it can get even better with some manual hacks. But I initially built this journaling tool, and I had it kind of ask me about my day, and I would just talk to it, and it would ask me questions. And then I realized actually there was kind of a therapeutic side to it that I really liked, so I modified the prompt. And then I was kind of surprised. I had a hard time demoing it because I would record a video, and then it would ask me a question. I'd be like, oh, that's a good question. I guess I'm not sure how I feel about such and such.
Yeah.
And then be like, well, I can't share that. And then you find like all these. I didn't set out to build this thing, but eventually I realized I could have it create a profile of me. So at the end of every conversation, I say like, here's the profile you created yesterday. Can you update it with facts about me, things you should remember, and I'll give this to you tomorrow. And so now it knows things about my marriage and my children and my activities and whatnot. And it asked me things like, hey, have you followed through on this? And I'm really excited to get access to the...
I think you're losing your mic, sorry. Just squeeze that a little.
I'm really excited to get access to the multimodal GPT-4 where you can also have images.
Quick description for those who missed that.
So these models right now are text in, text out. They are very rapidly going to be anything in, anything out. So images in, audio in, text in, similarly, images out, audio out. And as soon as I get that, I want to hook it up. I'm not saying this is something I would sell to other people or other people should do this, but I want to hook it up to my Apple Photos so I can see the pictures of my day, maybe the Spotify, what I'm listening to. And it can kind of ask me about it and say, hey, I noticed that you're spending more time with this person, or did you feel like you were present at that time? And just by building one piece, I suddenly realized, oh, it'd be really nice if it could do this. And the building has led me to explore more and more about these and become more enthusiastic about using them.
Yeah. For those who want access, I recommend checking out Mini GPT-4, which is someone took the Blip model, which is a image encoder, and wired it up to, I think, a Llama text model. So you kind of have it, but it's not as good as GPT-4 itself.
These models are also fantastic. Like, it's just been so fun. Like, I built a little thing where I asked GPT-4 to give me a random topic. I then used that to generate a random image in Midjourney. And then I used their API to describe what's in that image. And then I sent that image over to I have the ChatGPT plugin, and say like, the description. And I said, all right, based off of this description of an image, please write me a poem in English and French. And then I overlaid the two with nice typography. And every minute or 2 minutes, it just cycles on an art frame. And it's kind of like art that's just created, experienced once, and then just goes away. And the whole thing was like 3 hours of hacking.
Amazing.
It's really fun.
Well, we are out of time. This has been such a fantastic conversation. I'm so honored to have both of you here. Can we please give it up for Swix and Sean Grove, everyone?
Thanks for having us.
Thank you. All right. Thank you. What's up?
Great. Okay, cool. We're live. Great. Thank you. That was a really interesting conversation, and definitely always curious to hear more about AI and how it's going to affect our lives. So before you leave, I want to first of all sort of thank everyone. Thank you for coming. Thank you to our volunteers for their generosity, their amazing work ethic, Lifted Plate Catering for their delicious food, also Argus HD for their superb audiovisual, Congregation Sherith Israel, where we are now, for their beautiful venue, and basically just all of our staff and audio support, our speakers, our sponsors. Thank you all for being here. It's really great to see everyone in person this year, and it's gonna be exciting to keep doing this going forward. So some announcements. The expo and food stations downstairs are closed and have been broken down. So grab your stuff and then head to Hotel Kabuki for the after party. Also, don't forget there is an after party at 8 o'clock at the Boom Boom Room, where there'll be a special live recording of the Latent Space podcast, where we'll hear from Swix again, and also Alessio Finelli with a special guest, Wes Boss. So they'll be talking about the future of web development, in the age of AI. So don't miss that. It's just a 2-block walk from the Hotel Kabuki, so please be sure to bring your conference badge for priority admission and seating. So thank you all for coming again. We hope you had a great time. Feel free to tag us at Reactathon on Twitter with some photos if you have some to share, and we'll see you next year. Thank you.